Just to tell you a one-liner, Future Focus Infotech is an IT services organization running for the last 18 years in India, US, and UAE. And we service clients in the technology space, services space, and product space. Of course, there's no introduction required for Indian Mathematical Institute. IMOF, run by Durai. Durai specializes in creating product companies. He is a serial product entrepreneur. You will come to know both about Professor Rondajoy and Durai as we go along during the session. I must especially thank them for putting this together for us. This series is aimed at creating awareness about the various possibilities of using data, data sciences, data analytics, so on and so forth. And like we said, since it's a series, we will eventually, through our labs, through our product groups, come up with various products which will be cloud source, so to say, so that it could benefit everybody who's interested in them. The idea is to, in the simplest way that I can understand this, is the idea is to utilize the data that is knowledge and convert it into usable wisdom, insights, which is what so basically we are getting into converting knowledge to wisdom, data to usable insights. Thank you very much. I'm sure you'll have a great learning session. Professor, over to you.
Thank you. Thank you for the introduction. So my name is Rondajoy Adhikari. I'm a professor here at the Institute of Mathematical Sciences. I'll speak only 2 words of introduction about the institute itself. So this is an institute which does fundamental research in 4 areas: physics, mathematics, computer science, and very recently computational biology, where this is a completely theory institute, so we don't have experimental facilities. We're all pen and paper, blackboard, computer kinds of people. The institute was founded in 1962, so we have just recently celebrated 50 years. It was founded by the gentleman Alladi Ramakrishnan, in whose honor this hall is named. He was a physicist, and he was also from a fairly distinguished family of this city. His father was Krishnaswamy Alladi, who was one of the architects of the Indian Constitution. And if you have time, once this is over, there's a very nice exhibition downstairs, which I'll show you, and you can find out a little bit more about the history of the institute and what it is that we do here. So maybe I'll just speak a few words about how Dora and I got together. So as I said, I'm a physicist. I'm not really in the business world, but as part of my work, I do a lot of data analysis and understanding data from the algorithms and mathematics point of view. And Dora came through a very fortuitous introduction. And we figured out that there are actually lots of things that we could put our heads together and do. And one of the things we felt we could do was to actually build up a little bit of awareness in the city, since there is so much of energy and positive enthusiasm about data science here. So maybe that part of the program, I'll give it to Durai to tell you more about.
Thanks. Good morning. So nice to have you here. So it's like, and I was surprised. I walked in around 8:45, sat in another room, but I just came to check something, and then I already saw a few of you sitting here, and I said, that's awesome, lots of enthusiasm. My name is Durai. I'm going to be doing the first session, and jointly with Rondajoy, the third session. I'm a practitioner. We build products. I do some consulting work as a part of a products group of Future Focus. We are planning to build a lot of prototypes in this space, and I was looking for somebody with a strong theoretical foundation, and so we've been planning for doing that for a while. And last year I was lucky to come and meet Professor Rondajoy, and I think it's like chemistry happened within the first few minutes, because I walked in and there was this beautiful santur right there on his desk. And I said, do you play? And he said, yeah, I do. And then, even though I don't know much about music, and we started a conversation that way. Then within a few minutes, we found out that we both like the same programming language, Python. So it was like that. And then we started talking about various things, and we figured out, it'll be great to do something and just start from a very, very, very early stages on data science, and then do a series of workshops. So this is basically an introduction to the series. The series will be aimed at developers. So I would like to see a show of hands on how many of you are developers here? Okay, great. So rest of you, like, how many of you are like leads, managers, business people? Good. Okay, great. It's a great mixture. How many are faculty members from different universities or colleges? One. Okay. One, yeah, and two. So, okay, good. All right. So with that, let me get started. See, I'm going to do a very 50,000 feet view of this whole thing, because when I entered, I first, when I read about machine learning, do you want me to switch? Yeah. Yeah. So I first said, can machines learn? I mean, what is this? This doesn't sound like, humans learn. Can machines actually learn? What is all about? And I got curious, and I started looking at these kinds of things. And then I started doing some research, reading papers, and of course taking courses. Then I suddenly realized one thing. The moment I started taking the first course, there's a lot of math notation started appearing here, and then I said, wow, what do I do? And then I said, you have to go learn linear algebra. You need to know statistics. And then you start uncovering, and then you start thinking how little you know even to kind of enter into this field. And so I said, can I get an intuitive understanding of what is actually going on? And that is something we'll try to do it during the sessions today. What I also wanted to do was, to some extent, the terms are all kind of mixed in the industry. Sometimes you use big data, there is a data science, there is machine learning, there is analytics, there is visualization. How are they all related kind of stuff? And we'll try to show a little bit of that and try to see forest and trees kind of stuff, and give you some ideas. So let me start. Where is the PowerPoint? Where is it? No, it's fine.
I've never succeeded in this 100%.
Okay.
Yeah, that's fine. Yeah, I think that's fine. You wanted this back. Okay. All right. So let me do this. Oh, I have that too, right? Okay. So you start with the question, what is data science? And depending on where you look, the first thing you go to is, of course, Wikipedia. So I went there, and data science is the extraction of knowledge from data. And I'm normally skeptical when people say that you can extract knowledge. I mean, knowledge is, to me, is something slightly different, but hey, it comes from Wikipedia, so we'll take it from there. But there is something interesting. When you talk about data science, and we talk about big data, and the relationship is, one of the things that made data science kind of prominent and come into fame is because of these large quantities of data that people started accumulating. I'm not just talking about the Facebooks of the world, the social media, or LinkedIn, and all these things. They deal in the orders of petabytes, and now I think they're going to exabytes of data. So look at it this way. If you have 100 rows in a spreadsheet, You can just quickly look at it, and then you can probably understand it, sort it, filter it, you can understand it. If you have 1,000 rows of data, it's a little bit more difficult. If you have 10,000 rows, you need to go to some tool that visualizes the data for you. What happens if it's 1,000,000 rows? What happens if it is multi-million rows? Of course, Excel will croak, but besides that, how do you make sense of all this data? So, and humanly impossible. So you need methods to take you and somehow pull things out of that, because there are large amounts of information hidden in that data too. So if you really look at it, it's a methods to scale to big data or particular interest in data science. The development of machine learning used to uncover patterns in data. So that is the key, the patterns in data. How do you uncover patterns in data? So in the business data, you know what data you're capturing. You're capturing data about customers, about products, about support queries, about bugs in the product or defects and issues, all that. We already structured it because we wrote database schemas and we built all that. But when large amounts of feedback data is coming from customer support, how do you unearth what are people worrying about? If there are a lot of conversations going on inside product groups, how do you mine these conversations? And then there is, how do you go and predict? The 100 customers came into my site, 2 of them bought the product, 98 walked away. If a new customer or new visitor comes, is he going to convert or not? How are you going to predict that? So there are lots of very, very interesting prediction related stuff. So, and you will see this repeating, and we may be mixing up terms here, big data, machine learning, data science, and I'll freely use it, as if they're all the same, but you know that they are not the same. Big data is data, and machine learning is or technologies and techniques and to mine the data, and data science is a slightly bigger umbrella term, right? So it's all from the same page. I just took and formatted it, otherwise it was too much of a text. It is not new. It has come, actually machine learning is considered as a subfield of artificial intelligence. But machine learning is what now is powering, like making artificial intelligence very famous, right? So, and I don't want to go through this list, but you can see the number of things and some combination of these things you need to learn to go and work with data science. Okay. So what I'm going to do is I'm going to switch to a video. I'll do this dance a couple of times. Let me do this. And the inner video. Oh, not you. You may not know. Actually, there's another video.
Okay, well, welcome. Filter, and spam actually is an example of a. Okay, well, welcome. You're in the machine learning class.
Okay, so what I'm going to do is. No, it's fine. I'm just trying to find the.
For using it.
So this is
every
Tom
once in a while
Mitchell.
You'll see odd things happen on the screen.
And the slide is there,
So like this. What's this about? It's not even on my screen, but that's okay. So machine learning is a subject close to my own heart. It's about the question of how do we build computer programs that automatically improve what they're doing through some kind of experience. So to have a well-defined problem in machine learning, I'd say we need to have 3 things specified. We need to have some performance task that the computer is performing, and some metric for what it means to do that better or worse, and then some kind of experience from which the program can train. So for example, you're very familiar with spam filters, and you're probably aware that spam filters are trained using machine learning. So if we took that as an example, we'd say the task is to take an arbitrary email as input and produce a label spam or not. That's the task. the performance metric we would like to optimize, I could make up several random spam filter programs, but there's some performance metric that, for example, you know what your own spam filter, your own notion of spam is. And so there's some, if you were, for example, to label a set of emails as ones that you consider to be spam or not, then we could say our performance metric we might use to make a well-defined learning problem is to match as closely as possible the labels that you've assigned to the emails. That is for the program to learn to match as closely as possible your own labels. So that would be a performance metric. And the type of experience, well, it could be just what we said. It could be the experience the program's going to learn from is a set of labeled emails. This one's spam, this one's not spam, here's another spam. And so there's an example of a well-defined machine learning problem. We can make another one, also with spam. We could say, for example, we could change the performance metric. Maybe you...
So I basically just wanted to, instead of showing you the just that thing saying it's task, it's performance, it's the experience, I wanted you to listen to the person who was talking about it itself. So the method he is describing there was called supervised learning. You give it initial set of data, then you label the data. The label here is, okay, this email is spam, this email is not spam, and then you give it enough data, and then it starts learning the patterns. So there is a bunch of algorithms that go through this data and then look at the labels, and then they figure out, hey, this is spam, this is not spam. These are the characteristics, these are the patterns. You'll start finding out lots of interesting things. And if you ever try even a simple method of trying to do the spam detection, you will start coming up with very, very interesting patterns that come together. So that is one. So let me play one other video, which is a little bit longer, but it will give you even a better idea, and then we'll resume the presentation.
Than Carla without it, but every single one of them has
so this is actually a long video that goes on for about
wouldn't necessarily know how to do it.
An hour, but I'm just going to do the first few minutes of this.
And tell the computer to do it.
Oh boy.
And so what we do is we have, instead of having the programmers like lots of little programs, we have one big program we call machine learning, artificial intelligence, got different names, and there isn't necessarily just one of them. But there's variations of them.
VLC
and then we feed it some examples. For that. And a million. And then I can go to my diction, their name. I can't write down the steps to do that. And so I'm stuck. I couldn't solve that problem. So what do we do when the programmer can't come up with a solution? And the answer is computer to come up with the solution. If we as programmers can't do it, we can tell the computer to do it. And so what we do is we have, instead of having the programmers like lots of little programs, we have one big program that we call machine learning, artificial intelligence, got different names, and there isn't necessarily just one of them, but there's variations of them. And then we feed it some examples, and then the output of that program, rather than doing something, is it produces a new program. So it learns to write that program that we as programmers aren't smart enough to do. And then in the rest of this lecture, I'm going to show you some examples of what we can do with that. So, for example, making sense of word senses. What do I mean by that? Here's some example sentences. This is the word bank, and there's two senses of the word bank. There's the one having to do with money and the one having to do with the river. And one aspect of understanding language is you should probably know the difference between those two. We'd like to understand everything about those sentences, but I'm going to break it down and just solve that one little subpart of understanding language. And how are we going to do it? Well, we're going to feed some data into a program, and it's going to learn to write the program that will do that recognition. Because I don't know how to do it as a programmer. I don't know how to write the rules to do that. But I can gather up these examples. I can go search the web, find 1 million sentences that have the word bank in it, and throw that in. And then I can go to my dictionary and say, here's 2 definitions, and I can throw that in. And now I'm going to ask the computer, take those 2 things, list of sentences, list of definitions, and write me a program that will distinguish. And now I can feed it a new sentence, and it will say, this is bank 1, or this is bank 2. Now I'm going to tell you how to do that. So this is what it looks like. The sentences and dictionary definitions come in. We feed it into machine learning, and this program that decides the word sense comes out. And now I can take that program and I can give it a new sentence it's never seen before, put my money in the bank, and it creates a brand new, or it creates as the output, I know which sense that is. So how do I do it? Well, I start with these definitions, because that's all I got to begin with. I got these definitions, and I take out my scissors, and I cut up the definitions into individual words, and I take each individual word and put it into a bag. Now, this is a very formal mathematical model. It has a technical name. It's called the bag of words model. So we got that bag. It's got some words in it. We shake the bag up. We do the same thing with number 2. We take all the words, we throw it into there. And so now we got these 2 bags. One's got those words in it, and this other bag has got these words in it. And now we're going to say, I need a model of how language works. So there's lots of tricky things going on in those sentences. They're talking about actions that are happening. They're referring to lots of words. It seems like I need to understand something about how language works in order to answer this question. And so I need a model of how language works. And I'm going to start off with the stupidest possible model I can think of. And one of my heroes, George Box, the statistician, said, essentially all models are wrong, but some are useful. So we shouldn't mind that the model is wrong. And so my model of language is, when you want to create a sentence, you pick out a bag that corresponds kind of to the kind of thing you want to say, and then you reach into that bag and you pull out a bunch of words and you put them together, and that's how people make sentences. Now, I know that model is completely wrong, but we'll see that it turns out to be useful. So I've got these 2 bags, and now a sentence comes in, and I want to say, who made this sentence? Was this sentence most likely generated by pulling words out of bag 1, or by pulling words out of bag 2? And we see, well, there's only one overlap. There's one word in there that comes from bag 2. So probably it's more likely that this sentence came from bag 2. So I could label it as that, and I would get this one right. But more importantly than getting this one right, I can now update my model and make it better. So I can take all the words from this sentence and throw them into bag 2. So bag 2 is now bigger. I keep on doing that, and the bags get bigger and bigger, and they've got bigger counts for the number of words they've seen. They've got a larger vocabulary corresponding to each word. So each bag is becoming a better model of making sentences about bank 2 or making sentences about bank 1. And basically, that's all there is to it. Everything I need to know, I learned from Sesame Street. We call him the Count. You call him Grafzal, right? Right. So here he is making a determination that this is sense number 1 for this word. Okay, so we've done that. We just feed a bunch of sentences through. We keep on making the bags bigger and bigger. And now we've got this program, this word sense decider program. I can give it any new sentence, and it can tell me, is this bank 1 or bank 2? And I can apply it to these sentences. And it does a good job. But let's measure, how well does it do? And the answer is, it depends on how well you train it. So if you give it 1 million words of training data, I go out on the web, I find 1 million words of sentences that have the word bank in it. And remember I said there was one yellow box called machine learning. Actually, I lied. And there's different schools of machine learning that prefer different techniques. And they publish papers that argue about whose technique is better. And one of the papers described 4 different techniques, and they got these funny names. They're all different methods of machine learning. We don't need to go into the detail, and said, which one performs better? So when you give them 1 million words of sentences involving the word bank or whatever other word you want to decide about, this is the performance. The best one, the blue one here, does 85%, and the others are 80-something%. And so you might be tempted to say, yeah, well, the guys who are voting for blue, they're winning. But don't stop the discussion yet. Instead, we can go out and find 10 million words of training data, train it, and try again. And now everybody's doing better. In fact, everybody's doing better than any of the ones with 1 million. So all these people that we're arguing about, is my technique better than your technique, and who has a tricky new idea? Having a tricky idea isn't as good as just going out and gathering more data. And you can keep doing that. If you get 100 million words, it's better still. And now 3 out of the 4 were better than the best before. And when you get out to 1 billion words of training data, it seems like it's starting to asymptote out. We're not going to get too much more improvement. But now we're up to 97% correct. And we didn't know anything to start with. We had a terrible model of English. We didn't know anything about the syntax of English. We didn't know anything about the meanings of any of the words. We just had these 2 bags, and now we can solve this problem at 97%.
How machines learn. So we'll show the vocabulary related to data science. Okay, and the way we did was, one of our team members, I think he stayed up fairly late last night. There is a Twitter account called KD Nuggets. I'll have all the resources for you. They're like one of the top tweeters on things related to data science. KD Nuggets, KD comes from knowledge discovery. So KDD is been there doing this kind of data mining and knowledge mining and all that kind of thing for a long time. And it's a prolific tweeter there are a whole bunch of them. But we took all the tweets. Then we took all the hashtags in the tweet. And of course, we haven't used any machine learning algorithms here. We did very, very simple analysis. We took all of them. Then what we did was we had prepared long time back. We had been working on something called a tweet cloud. It's a program I'll show you in the 3rd session, where you can have a bunch of tweets, and then we can extract a bunch of keywords. And these keywords become linked to the tweets. So when you click on a certain keyword, it'll go and find out all the tweets with that keyword. It's kind of a nice Twitter navigator, but in this particular case, it's all related to data science, topics. And you'll see a prolific, if you really see a whole list, some vendors, some products like Azure, ML, and there are companies like SAP. There is Spark, which is an Apache project. There's a whole bunch of things in there, and then we'll navigate through this and that. But that is what happens when you go to a field first time. There is so much vocabulary, there is so many terms, there is so many concepts, they're all interrelated, and then it says, oh boy, am I in the right place? And do I need to learn all these kinds of things? And we'll show you that it's not really that bad. You can start really, really simple, and then you can move on. Okay. So we talked about data science, and we also encountered terms like big data, machine learning. So I'll spend a couple of minutes. You already saw some example of machine learning in Peter Novick's video. By the way, the second video, he's the search director at Google, and he also wrote a book on artificial intelligence, and he's a professor and teaches in Stanford and Berkeley. So big data is high volume. So when you say big data, the first thing, the name is a little wrong, because you think large volumes of data, but that's not the only thing. What about large varieties of data? Text, video, audio, what about animations? What about variety of data, right? In so many different formats, JSON, XML, relational database format, CSV files, and God knows what other formats. Lots of different formats of data. And what about the velocity of data, the speed with which data comes? Tweets come at a phenomenal speed. A company like Twitter needs to manage these huge streams. In fact, they give you tweets, you can go subscribe to a service, it's called Twitter Firehose. Firehose is where this water is coming from this huge quantity in a very fast rate, right? So this is basically, but to simplify, it is, now of course they're up to some 7 V's, and they got really fascinated by these V's, and then they're like veracity and so many other things. But volume, variety of data, and velocity of data, which is the speed with which data is coming. These are the 3 things that govern big data. So big data forced people, once you get petabytes of data, like you have zillion conversations going on Facebook, you want to mine the conversations so that you want to show the right ads to the right people, for example. How do you do that? Existing databases don't fit. After terabytes, they start having problems. So you scale them out. Even then it doesn't fit because you can't structure the data and put it. These are conversations. They have context, they have people, they have profiles associated with it. These are a very different kind of problems. But it's not just for Facebook. We'll talk about others also. So you may say, okay, all this is great. Sounds like a lot of theory and so many subjects here and all. Does anybody actually use this stuff? Who uses data science? There's 20 industries. I don't expect you to go through the list, but finance is there, retail is there, construction is there, transportation is there. There's a whole bunch of these industries that use it. But even more interesting than this slide is the next one, right? Somebody decided, I don't want to use the science data. I want to use the term machine intelligence. Okay, so we didn't introduce that, but right now read machine intelligence as data science. If you look at it, what are the core technologies? How is the enterprise rethinking of enterprise? Okay, rethinking entire industries, right? Kindle has come, and digital books are slowly eclipsing. Today I personally have more digital books because I can carry them in one device, just the convenience factor, and read them on multiple devices like my mobile device as well as a small tab kind of stuff, right? So entire industries are being rethought, okay? Rethinking humans, right? Like if you look at it, augmented reality and stuff like that, imagine the amount of data that is, that is coming in. Then this talks about support technologies, and this is a good one to do, and we'll provide a link for this so you can go and explore it. But this is the opportunity space. If you are in consulting, if you are building projects, you may think, there are all these vendors already there. What do I do? Hey, there are 200 cloud vendors, but still there is a lot of space for new cloud. They will, work out. So I have to tell you one story about Netflix. Some more slides on the pharmaceutical, biotech, healthcare. A lot of activity going on related to mining of data and trying to understand. The essence is you need to learn from data, okay? And then we call it value from data is because once you learn from data, you can create value for your company, for your product, for your business. We'll take one particular thing and I'll come back to the Netflix example. This is one particular company, American Express. They are like, we know them as a credit card company. They have a whole bunch of businesses, customer management, customer marketing, information management, loyalty marketing, that is, giving loyalty points, customer service, fraud detection. Of course, fraud detection is where credit cards first entered. They've been doing it for a long period of time, and it's getting extremely better. They will know. So, for example, think about this. I have a mobile device. I go from Chennai to Bangalore. Let's say I take a train or take a flight. If I take a train, what am I going to do? Sit in the train, keep on checking my email, keep on surfing, sending WhatsApp messages to people. So it knows that there is an intelligence that I'm leaving all these footprints there, and it can gather all this intelligence, and when I arrive in Bangalore and walk up to a shop and use my credit card to buy something, It doesn't have to validate. It knows I just traveled from Chennai to Bangalore. So, ideally, if you have a credit card that you 90% of the time use in Chennai and suddenly there is a Bangalore transaction or 5 Bangalore transactions, it is flagged as fraud. But now that you have this additional knowledge, you can say, okay, so this person traveled from here. Same thing from here to US or here to UK or any other country. The people can figure out, oh, for a while you'll blank it out, there is no use. That means you're flying. You don't have access. You land in there, you start using it, then you immediately find out, right? So all these devices are also adding to all these data points kind of thing. So how Wall Street uses, and again, I apologize for all these colors and print and all that sort of. I just took a screenshot from a tweet. There are successfully, this is an area called predictive analytics. They are able to go and find out from the sentiments of people of what is happening. Like for example, Apple has this new conference, they introduce 3 products, there are 1 million tweets. Apple does anything they sneeze, there will be 1 million tweets. And all of a sudden people are saying, what is the sentiment about this product? S6, whatever, like it's not such a iPhone 6 or whatever. It's not a big deal. Automatically Apple stock. So it's all traded on sentiment, and you can do sentiment analysis. The way you do sentiment analysis is like Peter Norvig's example of look at the words. You have a collection of happy words, unhappy words, and then you can say this tweet is happiness, this tweet is not so happy, and then if it is attached to a product, you associate that happiness and unhappiness. It's a little bit more context, but it's very, very interesting to separate out, filter the data, and come up with this kind of stuff. Okay. So this is one of my favorite examples. I'm still struggling with it, to be very frank with you. The large amount of documents. So I follow 7,000 people on Twitter, right? Obviously, I don't have time to read all the tweets. Otherwise, I need about 5 lifetimes and another 72 hours in a day. So what I do is I try to put a filter where I can just run through all the tweets and then look at the topics that they are talking about and find the hottest topics, go and look at those topics. Right? That's what I'd like to do. The same thing is true with documents. When you do e-discovery, in the case of a case, you want to mine, let's say, email conversations to see what is the team concerned about. Support conversations. Who are the customers who are shouting most? What are the issues that are coming up most? Literally everywhere from, that was my alarm. I'm supposed to stop now, but I'm going to beg another 10 minutes from you. Okay. Thanks. So this is a very interesting area. It's a kind of horizontal application. It's going and mining a bunch of topics. There is no prior data, no prior labeling. Just surface all the topics that are important, how they are interconnected, how you can use them, right? So there is a demand for data science skills. And this we can go through very quickly, but it's a bunch of McKinsey reports, right? McKinsey estimates that there will be a talent gap, nearly 200,000 people for analytic industry, not in 2050, 2018, 3 years from now. US cannot produce 200,000 people in data science. First of all, a lot of people in US don't want to take mathematics, right? In the high school level, they tried fighting that thing. So where is it going to go? It's not going to go to China yet. Maybe in 20 years that may happen. So there are huge opportunities for Indian companies. Speaking of buzzwords, these are all questions being asked to some university saying, what are you going to do? So somebody, I think, published an article saying data science is the sexiest job of the century. Of course, obviously, sensational, like headline making kind of thing. So what do you do? Working in big data, proficiency in numerous disciplines. We saw that big list of disciplines. So how are you going to get proficient in all these disciplines? What is the new course that the university is going to design that are going to get people into this, right? So that is McKinsey. That means there are always, all the big businesses are listening to them, right? Talk about the US. The only thing that I want to read out about, 7.8% of all employment in the US are for data related jobs. 8%, close to 8%. And it will follow everywhere in Europe, in India, and all these kinds of places. This is government published data. This is not some analyst making up something and then publishing that information, right? So our own place, Flipkart. I was surprised when I saw this advertisement and said, we are looking at lots of interesting and challenging problems that can create huge business impact. They want data scientists, interns, and data scientists. You know why interns? Because you can't find data scientists. It's difficult to find. Go try finding them. They're very difficult to find, right? Because it requires a bunch of skills. It requires very good programming knowledge. And, so companies like Flipkart, because now Flipkart is like Amazon. What is the first system Amazon, most famous for is the recommendation systems. You buy this book, friends like people like you also bought this book. And I always click on those books and buy them because, it's like a very interesting. But it's not very simple. It's not just mining the book buying records of a lot of people. It's also understanding what is your profile based on the books that you read. Now that they have Kindle, they even know how many chapters in the book you have read, because it is syncing with the cloud. So it's not as if so I have 200 books, 150 on the shelf unread, 50 of them, 2 or 3 of them I read like 2-3 times. They know exactly what my interests are based on my actions, not based on what I say. And you can gather all this data. And they're going to try to do all these applications, right? If Flipkart is there, and everything will come behind. I always go to this site called Indeed.com. It's a job site. It gives you job trends. And then I went and typed in some terms like big data, data scientist, data analyst, data engineer. And they are all slightly different roles, but in the same space. And this is the kind of jobs, and analyst is right there, up there. And these are all like slightly below. This is what is called the absolute trend. There is a trend called a relative trend. Relative trend is basically how fast are these jobs coming up and what is the gap between the jobs being posted and the being filled. And how fast are these jobs rising? All of them are rising, right? Except maybe data engineer, because data engineer is a lot more of an infrastructure play, and already for that you don't need to learn all these many things, and it's mostly formatting data. So all the people who worked in data warehousing, BI, those skills are already there. So you can tap those skills from there. So finally I said, okay, we talked about data science, and we talked about showed what do these data scientists, what are these creatures, what do they actually do, right? I want you to take 1 minute and just watch this stuff. This is what my grandma thinks I do. This is what, oops, sorry. Okay, so it may be slightly difficult to get the joke, but the last line is this guy is just using a library called scikit-learn, and it's a Python library, and he's doing all his data science work. And this is the perception of what he does in the rest of the world kind of thing. So it's a slightly light-hearted one. But this is 10 things that they do. And we have gone through some of these things before. You'll be surprised, even though their algorithms play a very important part, and they're the core in the machine learning, there's a lot of stuff you need to do. You need to find out what data to acquire, how to acquire it, how to format it, how to make sure. And if there are lots of dimensions of data, how to reduce the dimensions. These are all challenges you need to. So it's kind of a very iterative process. You start out with some data that you have. For example, let me give you a simple example. We have a product. We have a bunch of people who have come and tried it, and a bunch of people who paid for it. And the people who pay for it is a small percentage of the people who tried it. So I want to find out, hey, if a new guy comes, should I spend time with him or not? Is he likely to be a buyer, or another one of those guys who does trial and then vanishes? So what are the patterns? There are 2-3 patterns. One is that if a guy signs up with a company email, the chances are that he's serious about buying, because people will put their personal email first when they're just trying. Generally, one behavior pattern. Another behavior pattern is, has he tried the product a lot? Did he use it in the first few days? And did he get these alerts that he is supposed to get? So you mine all that behavioral data, and then you feed it to the system, and then you already have records of who converted over the last 3-4 years. You say, these are all the people, this is their behavior, this is what these people bought, these people didn't buy. Very similar to the spam filter example we talked about. What is the likelihood? What is the probability of this new person coming, buying, right? So you need to find the data, you need to find out which features, are you capturing? You need to even go back and say, oh, we are not capturing this information. We should go and put a website and capture that information in all these kinds of things. So again, I'm not going to run through this. But generally, data discovery and collection, understanding of mathematics and statistics, write code obviously, have some domain knowledge. I think one unsaid thing is the empathy for the customer's problem. You first need to understand the problem, and if you don't do that, none of these things are going to work. But you also need the ability to tell really good stories with the data, because that is ultimately what the management is going to see. You go back and give an insight, like somebody was giving an example, it's not mine, but I happily borrowed it, is that there was another event where somebody was talking that this restaurant was trying to do this analysis, and then there are lots of problems, and then they found that a lot of people were not eating food. So they went and did analysis and then got all the data, and then found out that all the guys who didn't eat much were people who ordered these 2 liters of water before. And because they ordered 2 liters of water, they didn't want to take it out, and then that was the only thing available, either 1 or 2 liters. They kept on drinking it, and that's why they had no need to eat. So they went and changed that when you order water, they give you a small bottle which is like 200 ml. And they saw actually spike in their sales of all the other items. This is like a very, very practical, I don't know if it's true or not, but it's a very interesting example that will stick in your mind about data. I'm going to skip this because too much of text in this. So there is a pyramid. So at the bottom you see, bottom not means it's bottom, it's just a large number of people are required to do this kind of thing, data engineering. See, if you have a large amount of data, you need to also set up infrastructure, distribute the data, process it, bring it back, and do all kinds of things. The ML engineer applies algorithms, it can also be analyst. ML researcher goes and creates new models, and that's one of the toughest, right? And that's what Professor is going to tell us how to do in the next session. So how do we start? And I'm almost towards the end of this. So first think about the problem. What problem does it solve? And for whom? How is it being solved today? So machine learning and data science are not the solutions to every problem. A lot of them, there is no fit. So you need to understand what they are. What are the others who solved similar problems in other industries? What did they do? How can it beneficially affect the business? So you can go through all this kind of thing. In the end, is it going to save me some stuff? Is it going to make new money for me? And anything that says, with this I can make more money, convert more customers, you're definitely going to get more sales. So there is a cycle, discovery, and prepare data, then you create the models, and then communicate the results, and then go through the cycle several times, and then you finally operationalize it. Okay. Then you build data products. This is one of the businesses we are planning to be in. So build these data products and distribute them. The levers are all the parameters that you can tune, try to control the level of insights that you're going to get. Then you go and pick a good programming language to do all this kind of thing in. And this is based on the analysis of data science job descriptions. Somebody else did the analysis. I found the graph. I said, okay, I stole it. So it's here. The reason Python is very interesting is that why is Java number 2, even though Java is the most heavily used language in the enterprise? Python is number 1 because Python you can experiment a lot. You can write a lot of throwaway code. In the initial stages of building, you will just keep building and throwing, and you're trying to figure out, and you can just anything you want to think you can code in a few hours. Okay, and then of course there are the other languages. Pick a good library. Because I said Python here, this scikit-learn. This is the guy who said, what does that last slide of thing about what people think he does versus what he does. We are going to cover all this in the next session. And just to make you slightly dizzy, there's a lot of open source tools. One of the nicest things about data science is the number of open source tools that you have. And then of course you're not going to go use all of them, and we are going to experiment with a bunch of them. We'll share our knowledge with you, and you can do that. And I don't know whether that email works, but we'll make it work. With that, I'll give it back. I can take maybe 1 or 2 questions, just to make sure that you got something I talked about. So, do you want to come and set it up?
While Durai is taking questions, I'll set this thing up.
Any questions? I don't know. Wow, you're a silent. Oops, sorry. Okay. Go ahead.
Sorry, my attention was deflected trying to set up the, could you just repeat your question just once, please?
Last part.
Just, yeah. Here at the institute? Yeah, there are, certainly. Yeah, but the opportunities would depend really on the kind of background that you have already, and also the kind of problem. Oh.
People who study here or
As interns in his company.
Oh, the other way around. Yeah, absolutely. I mean, sure. I mean, but again, I mean, our students are geared towards academia. Now, we have to figure out first if there's actually a good fit between what our students know and what your requirements are. And I think part of one objective of these series of workshops is to try and see if we can actually bridge that gap. So if you let us know exactly what your requirements are, we'd be happy to see if some of our students, yeah. Sure.
I'll try to give you
Yeah.
one answer. I asked a lot of PhD candidates what they want to do. Most of the people I talked to said they want to go back to academics. They like doing research. In fact, I think I remember I talked to one professor and he said that we take a couple of years just to find the right problem to solve in mathematics. So maybe that'll change because I think they do a lot of pure mathematics and abstract research. Maybe this year's but we'll see. But at least a lot of masters in mathematics guys are there who are not like, they don't as soon as they see a bunch of equations. So that may be a way to do it. Another question? You're ready?
Yeah, no, I think I'm sort of reminded of another situation which happened. Since you raised this question, maybe about 15 years back when I was a graduate student, a lot of my fellow graduate students, not in India, but much more in the US, actually moved to Wall Street. And they moved from physics. And the reason was that, all this financial mathematics was just becoming a hot thing there. And, the physicists were the ones who were actually trained with that kind of mathematics. Surprisingly, it wasn't the mathematicians. And again, I think we have a similar situation here that, all this stuff about machine learning and intelligence and things like that, those skills lie more with the physicists rather than with the computer scientists and the mathematicians. And, you're again likely to see, perhaps again, the trend will probably be initiated in the US, and maybe it'll catch up here soon afterwards, that you'll see a lot of people from academia, especially from physics, moving into these kinds of areas.
So, the session back.
Okay.
Thank you, Dora.
Yeah, thank you. Okay, can you hear me at the back at this level? Yeah. Okay. Right, so yeah, good morning once again. So what I'm going to do is take off from the very nice overview of applications that Dorai has given. What I'm going to do is focus a little bit on the theoretical side of things. So Dorai has spoken a lot about the applications and the opportunities that are there in the business and so on and so forth. What I'll try to do is tell you what is the underlying theory, what is the underlying mathematics, how do you actually start from ground up if you're trying to build a data science team or if you're actually trying to work on data science algorithms. So the axiom that I will begin with, in mathematics we start with axioms and follow on to theorems, is that your organization does actually need data science and it will benefit from that part. So and I'm just going to take that as a given and I'm going to proceed from there onwards. So this slide is a different version of the kind of thing that Dorai has already spoken of. And it says that what is the profile of a current data scientist. And you can see it has an enormous diversity of skills. And it seems to me it's just impossible that any one person could actually have all these skills embodied in one individual. So you need to know mathematics and statistics. You need to be a great programmer. You need to have domain knowledge. And you need to be able to communicate all your results. Okay, so now that's a very, very tall order for any person. I guess that's the reason why all these data scientists are actually not available at all. You've set this bar so high that you cannot actually find anyone with these sets of skills. Okay, so what I will try to do is, since this mathematics and statistics and to a certain extent programming is my expertise, I'll try to bring in the focus from there and try and tell you what is it that is there in mathematics and statistics and programming and databases which is useful for any data science task that you might have at hand. Okay, so that is really going to be the focus of my talk. There is this angle of visualization here. I think somebody, when I was looking through the responses of what people wanted to know about, somebody had said that they're interested in data visualization. That's an extremely important part of this entire exercise of taking data and acquiring value from it. So I'll say some words about data visualization, not too much more. So my talk sort of hinges on this slide. I'll talk about math, statistics, a little bit of programming, and a little bit of the communication and visualization part. Dorai has given a large and nice overview of what is the kind of domain situations you need data science for. Okay, so there is lots and lots of data, but where exactly is the science part of this? Okay, so when we as scientists conventionally use the word science, we mean at least a subset of these things, that you can make an observation. From that observation, you can make a hypothesis. You can sort of try to validate your hypothesis by further observation. And through this cycle, you ultimately arrive at theory. And theory embodies some understanding of the question or the observation that you actually started trying to do. So now, in this space, if we are really to call this science, as opposed to just data mining or whatever, any other adjective that you want to give it, if you really want to call it science, you really need to ask yourself these very sets of questions. What is it that you're observing? What kind of hypotheses are you trying to make? What kind of experiments can you do if you have a hypothesis? Okay? And finally, after that, what kind of conclusion or theory can you arrive at? Okay? So just like in any usual scientific process, this entire exercise of data science needs to go through this kind of life cycle to arrive at conclusions which are deemed scientific. Okay, and I'm going to motivate this. So for those of you who are at this earlier thing that Ohm Analytics had done, you might find this already familiar. I'm going to motivate this life cycle of observation, hypothesis, experiment, and theory through a very, very old example. And the old example is it's the Egyptian civilization. Okay, so they were in my opinion, they were one of the earliest data scientists. So this was one of the oldest agricultural civilizations, as you well know. And their existence and their prosperity and their well-being depended absolutely very crucially on the floods of the Nile. If the Nile River did not flood, there would be no agriculture, there would be no surplus, and there would really be crisis in the civilization. So if you now think of these guys as an organization, as a big organization, they are crucially dependent on the flooding of the Nile. It's very important for them to understand when is there any sort of cyclicity in it. Can I say beforehand, even before the floods have come, that this is going to be a good year or a bad year, or so on and so forth. And you can see a little bit of this already in the very great importance that meteorology has for our country. Our country depends crucially on the monsoons. The government invests huge amounts of energy and effort trying to predict beforehand whether this year's monsoon is going to be good or bad. And you can see stock markets being fluctuating according to what the prediction of the Met department is. Okay? So it has a big impact on your economy, whether you're going to have a good monsoon, lots of crops, surplus, etc., blah, 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 and so on and so forth. So the Egyptians had a very similar situation 2,000 years back. They were maybe 5,000 years back, actually. They were trying to figure out the flood levels of the Nile. And it's a remarkable thing that they actually started collecting data. They actually dug, so their process of data collection was upstream. They actually dug a very deep well into the bed of the Nile, and they would monitor the level of water in that bed. And that level of water kind of gave advance warning at least about a month, 2 months ahead as to what the flood levels are going to be for that year. Okay? This is the data set. Okay? It's one of the oldest data collection exercises. And from this data set, they would make some informed guesses. So what is this data set of? What is the x-axis? What is the y-axis? So this is year, and that is some level of water in the well. Okay? So every year, they're monitoring the level of the water in the well. And when the water level is low, those are the years in which you have a flood, a drought. And when the water levels are high, those are the years in which you have a flood. Okay? So I'm just giving this as a motivation. This is the kind of thing that you need to do. You are making an observation. You're making an observation which is important for you. Unfortunately, at that level in which they were, they couldn't actually make a hypothesis because you didn't know enough about physics, you didn't know enough about how rivers work, and so on and so forth. So the hypothesis part was clearly absent, but nonetheless, they could derive actionable insights from their data. And all the mathematics that was developed was actually trying to catalog through this cataloging of these kinds of data, various kinds of measurements, etc., and so on and so forth. So it did actually drive a little bit of theory at that point in time. Okay, and so now this entire thing I'm going to again emphasize is that you must have a need for collecting data. You must have the resources for being able to collect the data. And from these two things, you must be able to draw an inference. Some useful thing that you can infer from the data, which is going to satisfy this need for which you started doing the data collection in the first place. Okay, and these are not one-way processes. They sort of all feedback on each other. Okay, so your need will kind of dictate what kind of data you collect, or in certain senses, if you have restrictions on the kinds of data you can collect, you may probably have to modify the kinds of inferences you do that can feedback. So there is this entire feedback between these three parts of this entire data science exercise. So I think I missed my last conclusion, which is, so what we're trying to do at this point, 5,000 years after the ancient Egyptians started doing this, so instead of having scribes who are doing this, sitting here, we're trying to do this by a machine. Okay? This entire process of collection and inference, we are trying to do through computers. We are trying to automate this process. Okay? And that is the whole idea of trying to develop algorithms which can automate this process. And this process is the machine learning process. Okay? So my talk, again, Durai has given a lot of different kinds of algorithms. Okay? So in this space of algorithms, there are many kinds of algorithms. The ones which I'm going to focus on are really the ones which are called machine learning algorithms. I'm not going to focus on the entire body of data science, statistical, etc. algorithms, because that's just an unmanageable task to do in one talk. I'm going to focus specifically on the machine learning algorithms because they're the ones which are actually the most frequently used, and they're the ones which actually can be said to do the learning process. So just like we think of human learning, these are the ones which best mimic that process. And these are really the hottest sort of algorithms at the moment. And I'm going to focus only on those algorithms for now. So this is again a slide that Durai has shown you. So this is the sort of machine learning skills pyramid. What are the kinds of people who are involved in machine learning? And this pyramid is divided into 3 parts. There's the data engineer, there's the machine learning engineer, and then there's the machine learning researcher and the scientist. Okay, yeah. What keeps twitching? The slides. Slides. Is that better? Let's hope. Yeah. Okay.
No, see, it's still happening there.
Is it still happening? Yeah, absolutely.
No, I think it's got to do with the refresh rate of the screen.
Okay, I can try to fix that. Yeah, it doesn't seem to be the refresh rate of my screen. It seems.
Make it 75.
Okay. That makes it worse. Okay. Let's try once more. Any other suggestions from the audience on what modes I should try?
Maybe some loose connections.
Yeah, that seems to me more likely. So let's see. Okay, anyway, if you just bear with me, I just have 2 more slides. So I'll go to the board after this, and there'll be no twitching there. So okay, so please do bear with me. Okay, so this is, in fact, I can't see it very well from there myself. So this is this pyramid that I was talking about. It's got the data engineer, the machine learning engineer, and the machine learning researcher and scientist. And if I fit in anywhere, it will be somewhere here. So the view that I'm going to tell you about is really from here. It's the view looking down. And what Durai was talking about was more like the view looking up. What is the application end of things? Okay, I'm going to try and tell you about the algorithm ends of things. Okay, so as I said, I don't have too many more slides. The rest of it, since you will be subjected to. Yeah, but I'll just sort of, so I'm used to talking on the board, so you will have to bear with me talking on the board for a little while. Okay, so here is this skills pyramid that Durai has flashed out. What I'm going to do is draw a different kind of skills pyramid. Okay, this is not really a skill pyramid. It's more like it's not a very good pyramid also. It's more like an abstraction. It's more like a sort of abstraction pyramid. Okay. So at the lowest level, I want to write down the abstraction. What is this an abstraction of? This is an abstraction of the problem that you're trying to solve, whatever the problem may be. Okay? I want to look at it very generally, not sort of X problem or Y problem. So there is an abstraction layer. On top of that abstraction layer, you build a layer of algorithms. And finally, on top of the algorithm layer sits your application. Okay? And this is really the space that Durai was talking about, that the many kinds of applications that you might have for your particular need. But underlying them will be an immediate layer of algorithms, and underlying that further below will be a layer of abstraction. Okay? So what is happening at each layer? This is the layer at which you're doing some mathematics, all the linear algebra, etc., those things that Durai was talking about, various kinds of mathematics. on top of this sort of abstract layer of mathematics, there will be programming here. And on top of these two is finally your application, which ideally should have this kind of structure that in the best of worlds, that you send in data and you get out insight. In the best of worlds. Okay? Ideally, you'll never see such a nice, clean workflow. But ideally, this is the ideal thing that you would like. You like to have a black box in which you send in data and out comes some useful inference. Okay? So now, I want to go all the way back down to this layer. What is really going on here? What is the basic thing that is there in machine learning which is operating at this layer? Now, this is stopped? It's still flickering. Okay. So this is really the key abstraction which is operating at this lowest layer. We need to take decisions under uncertainty. If you knew everything about your customer, if you knew everything about your employee, if you knew everything about the market, there is no need for data science. There is no need for algorithms. There is no need for any of this. You know everything about what you want to do. You can take an action based on that. The entire reason why you need to do all of these things is that you do not know what are the behaviors of your customers. You do not know what are the behaviors of your likely competitors. You do not know the behavior of the markets. These are all things you're trying to guess. Okay? So, and depending on how you guess what you think, you will take a certain action or a certain decision. So from an abstract point of view, the problem really is that you need to make a reasoned decision in the face of uncertainty. Okay? So you do not want to take an arbitrary decision. There has to be an element of reasoning in your decision, but those decisions are modified by the fact that you only have incomplete knowledge of the thing that you're trying to do. Okay, so just going back to this example that I was talking about, and several more, again, motivated by what Dore has been saying, is that for instance, for the ancient Egyptians, the question of how much the Nile would flood would certainly implicate any decision to invest in dams. So for instance, if you know that this year there's going to be a massive flood of the Nile, you would probably want to invest in some of your resources and energy into building a dam, which would stop the devastation of a very bad flood. If you're interested in some equipment, computer equipment, manufacturing equipment, etc., you would like to know when this equipment might fail. And depending on what answer you get, because the failure is going to be something which you do not know when it's going to fail, depending on what your answer is, you may want to build in redundancy. You may want to have a backup machine or several backup machines, depending on what the failure rate is going to be. If you're looking at spam, if you're looking at email, if something already tells you that this is spam, you're not going to waste your time trying to read that. You'll just delete it straight away, right? But you need something to tell you that it's spam. Otherwise, you'd have to go through every single mail that is there in your inbox. Okay? If you're looking at job applicants, you have a record of what the past history of that applicant is. From that record, can you say whether this applicant is likely to be a good fit for your organization, right? If the answer is yes, you'll probably stop looking for further candidates. If the answer is no, you'd probably want to look for more candidates. Okay? So there is this whole spectrum of things in which you have uncertainty. And depending on what your answer is, you'll have to take a decision. Okay? So now you have these two opposing things. On one side is uncertainty. On the other side is taking a reasoned decision. So it seems that you're actually operating with two antagonistic things. So reasoning means that you want to do something which is logical. Uncertainty means that there is something which is chancy, which is probabilistic, for which direct reasoning does not apply. Okay? So this is where the beauty of this area from a science point of view comes in. There is actually a framework, a mathematical framework, which combines these two antagonistic parts. Reasoning, which is dictated by logic, which is dictated by Boolean algebra, which you might have studied if you have an engineering background or so on and so forth, which is the algebra of variables which are either true or false. That's how you do logic. You do logical reasoning using Boolean variables. And then there is this whole mathematics behind chance or probability, chance, uncertainty, so on and so forth, which is usual probability. When you're throwing a dice or several dice, you have probabilities. Okay? Once you combine these two things, that there is a logical aspect to your problem and there's a probabilistic aspect to your problem, you get something which is called Bayesian probability. Okay? This is the probability not of frequencies of, I do 10 throws of my die and what is the probability I'll get? 6. It's not that kind of probability, or how many times do I do something and how many times is the result what I want it to be. It's not that kind of probability. It is the probability of statements. It is the probability of logical statements, just like reasoning is the algebra of logical statements. Okay? So I'm going to focus on this a little bit more because this is really the key to understanding this bottom layer, the layer of abstraction. Okay? So what is going on here is that I'll give a very simple example. And I can take a poll on this. So I don't have a coin, but if we can produce a coin, and I ask you, okay, Dora is producing a coin for me, thankfully. Okay, someone has beaten it to it. Okay, maybe 2 coins. Okay, lots of coins. Okay. So how many of you have watched this classic Hindi movie called Sholay? Hands up. Okay, lots of people have watched it. Okay, so you remember the coin, right? It was a 2-headed coin. So, and Dharmendra got fooled repeatedly by Amitabh Bachchan because of that 2-headed coin. So now I have this coin. One of them has been given to me by Dora and the other by this gentleman. By Jagadish. Okay. Now, so I know that Dora is a scamster, so he's definitely going to try to scam me. Sorry, just joking. Okay, so now, I'm going to toss this coin. So the question now is this a fair coin or is it a biased coin? Okay, how do I know? So if I did like 100 throws and this coin came up heads, let's say 50 times, I would say that the coin is a fair coin. Okay, but now let's say I just do 1 throw. Okay. And it comes up heads. I do 1 throw, and so here I'll write the number of throws I've done and what result I got. I do 1 throw. What can you say about this coin? Is it a fair coin? You can't say with 1 throw, right? So, but can you say anything at all? What can you say? It definitely has a head, right? So it could be a completely biased coin which only will come up heads, right? This is the only thing you can say under 1 throw. You can say that it's a coin which may be completely heads, always. All throws will become heads, okay? If I do, let's say, 2 throws, and I get head and head again. Now what do you say?
Say the first and more strong.
So now is your confidence in this being a biased coin increasing? So it's increasing, right? So it's more likely to be a biased coin than with 1 throw. Okay. Now at n equal to 3, supposing I got head, head, and tail, right? Now you know for sure, one thing has become certain at this point of data, that it's not a completely biased coin, right? So it can throw up tails, okay? But then what is the probability? You've got 3 and 2 heads, okay? Supposing I did this. And I got head, 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 and tail, right? So no, the other way around. Tail, and then again I got a head. Now what do you think? What is going on now here? Sorry? So yeah, so at this point, what should you say? I got 3 heads in 4 throws, right? So this looks like it might be a biased coin, right? But if I keep going all the way down and slowly these numbers start converging to say half and half, then I would say it's not a biased coin. Okay? So this is how we learn. We learn from experience. We do something, we get a result, and then the result itself changes our state of knowledge about what is happening. Okay? So this whole process of going from a situation where I thought this was biased completely based on this. This is the only logical statement I can make at this point in time, right? Whether it's true or not is moot. What is the logical statement? What is logically consistent with my data at this point in time is that I have a completely biased coin, okay? And as I go down, I say that, it may be biased and when, say, I've made 100 throws, n equal to 100, and I've got maybe whatever, some stuff, and about, say, 49 of them are heads and maybe 51 of them are tails, I would probably say this is a fair coin, right? So this is my entire process of learning. I have data. Data is coming in at me through a sequence, and my state of knowledge is also changing as a result of that. Okay? So this process is the learning process. Okay? And if you remember what was the name of the gentleman that you showed, the Google scholar? Yeah, Peter Norvig. Yeah, so he shows this example of detecting the sense of words, right? You have bank as river bank and bank as a financial bank. And as you throw more and more data at the algorithm, it gets better and better at distinguishing between which sense of words this is presented in the sentence. Okay? So it's very much at a conceptual level, because as I said, I'm only going to look at the abstraction level here. Okay? At the level of abstraction, it is no different from doing this. Okay? So you can just think of these things, the throws of the coin, as the number of sentences that are coming to you, and the output as whether this coin is biased or unbiased as the sense disambiguation. Is this a river bank or is it a financial bank? Okay? So this is this entire learning process. Now, this learning process, how is it formalized mathematically? It is formalized mathematically through this thing called Bayes' theorem.
One question.
Yeah.
How do you decide how many samples are enough?
How do you decide how many samples are enough? That's a very good question. Okay, so if you let me just postpone that question to a little later, I'll come back to that. Okay, so that's a very important question. When do you have enough data? And if you've been watching the slide that Durai showed you carefully, you would have noticed that the gentleman Norvig has a graph like this, which does that, right? So this is the ability of the algorithm to discriminate whether you're getting the sense right, and versus this is the amount of data that you get, right? So for very low amounts of data, the algorithm is not able to discriminate very well. Whereas as you increase the amount of data, it starts discriminating better and better. Now that's exactly the same as this, right? At this point, you really can't say too much. But as more and more data accumulates, your answers become better and better. Now, what is enough data is a very, very tricky, at least from the theoretical point of view, it's a very, very tricky question. And there's no universal answer. It depends on the kind of problem and the kind of probability distribution that is involved in it, and so on and so forth. Okay? But typically, this question is answered at an empirical level. Okay? Rather than from a theoretical level, it's answered at an empirical level. You just try out sufficient amounts of data, and then you will see that your performance actually changes at certain points. So in this particular problem, that would roughly be a place where you say, I have sufficient data. Okay? Where, let's say, you could arbitrarily draw this to be 80% success, and then you say, okay, I'm okay with 80%. Okay? And then that's when you have enough data. But this is completely a sort of problem-dependent thing. Okay, right. So as I said, what is the mathematics behind this? So I'm going to take this out. The mathematics behind this is something called Bayes' theorem. And that tells you if A is a proposition, some proposition, B is another proposition, let's say. So this could be a statement like, okay, right? So it could be Durai is the source or Jagadish is the source, okay? I have two propositions, okay? And I want to ask this question. The question is this: probability of the proposition A, what is the probability that the coin is fair? Now, life is conditional. Most things are conditional, okay? Some action is conditioned on other kinds of actions. This thing, this very important property is indicated by this bar, okay? This says what is the probability of this proposition conditional on this proposition? What is the probability that the coin is fair given that Dorai gave it to me? Okay? Compare this with the probability that the coin is fair given that Jagadish gave this to me. Okay? Now this is the kind of probabilities that we are interested in real life. What is the probability that I should build a dam? Rather, what is the probability? So this is typically the probability of the action that I'm interested in, conditional on what is going to happen. Okay? What is the probability that the email that I have seen is spam? Okay? This is the kind of probability that I'm interested in. Okay? So what is the probability that it's spam given that it came from some source A? What is the probability it's spam? It came from some source B, etc., and things like that. Okay? So now this thing, which I will write abstractly as AB, where B could be either one of these propositions. Okay, and this is really the heart of all machine learning algorithms. What it does is it inverts these two propositions. It turns it around. Okay? So it turns it around into probability of B given A into probability of A divided by probability of B. Okay? Now, you can see what is the utility of this. Okay? What has happened here is that this conditioning has been flipped over. Okay? What is this probability? This is the probability that what is the probability the coin is fair given that Dorai is the source. Okay? It has turned the proposition around. Okay? Coin is fair, sitting here. B is Dorai is the source. Okay? Coin is fair given Jagadish is the source. Okay? So you can now see where this I did not know because I do not have sufficient information to model it. But once I turn the conditioning around, depending on what I think about Dorai, I can assign a probability to this. Depending on what I think about Jagadish, I can assign a probability about this. Okay? If I think that Dorai is definitely out to swindle me, I'll assign a very, very low probability to this. I will say that, oh, Dorai gave this to me, the coin has to be unfair. Okay? Or if I think that Dorai is absolutely an honest person, I would put probability 1 here, saying that, Dorai gave this coin to me, it's definitely going to be a guaranteed thing. Okay? So this is where this ability to turn the problem around from something which you cannot calculate to something which you can calculate is the basis of all machine learning algorithms. Okay? Because once you turn this around, this probability can be modeled. It can be modeled mathematically. Okay? And I'll show you how this can be modeled mathematically from a very simple example. Again, the one that Dorai outlined about Peter Norvig's example of word sense disambiguation. And that's essentially the same algorithm that is used in Bayesian spam filtering. Okay, so instead of using that algorithm, I'll just talk about Bayesian spam filtering because it's exactly the same thing. Okay, so this, if there is any one take-home message from my talk, it is this. This is the heart of machine learning algorithms. Anything that you do in machine learning will be cast in this form. Okay, and where is the learning part? The learning part is the following. Supposing I have never met Dorai before, I have never met Jagadish before. Okay? They are just two people who have just given me 2 coins. Then I have no idea about what they are likely to do, what is their likely behavior. So then, at this point, I should assign probability half to the ability that they will give me a coin which is fair or not fair. Okay? So I'll assign half. So this is I'm looking at them in a completely open-minded way. And then I look at the coin, okay, and I do my experiment. And then it turns out maybe the coin that Dorai has given me is fair, and the one that Jagadish has given me is unfair. Okay? Now, this probability I now have here is now conditioned on this, who gave me the coin, right? So when I go next to them to pick up a coin, I've already gone with this preconception that Dorai will give me a fair coin and Jagadish will not give me a fair coin, okay, or the other way around. Okay? So now this whole thing that I started with, I had no bias. I see my data, my bias builds up, and when I confront the data the next time, I use my previous experience to understand the data. This whole cycle, which goes again on and on and on, is the learning process again. And it's again related to the sequence of coin tosses that I was telling you about, okay? So this is the learning process. This is the machine learning process by which you take a probability, filter it through Bayes' theorem, and you get a new probability. And then again, you push this probability back again here, and you keep on doing this, okay? So this is the learning process. And all machine learning algorithms are essentially built on this idea. So in this case, so that's what I'm saying. So when I see the coin, when I do the experiment for the first time, P of A is half. I just assume that the coin is likely to be, equally likely to be fair or unfair, because I do not know any of them, right? And then I model this again as half, okay, because I don't know. So there are two aspects to it. What is my, so the way to model it is this. Supposing Durai and Jagdish are both people standing in Las Vegas, okay, in front of the casino, right? Then, even before I know any of them, I should develop a bias that they're out to cheat me, okay? But if Durai and Jagdish are sitting here in this hall, okay, as participants in an academic conference, then I should start with this being half, okay? So there is always a part of the problem which does not involve the participants themselves. It just involves me, okay? So the participants are not involved here. And there's another part of the problem which involves the situation that I see independent of the participants. So if I'm in Las Vegas, this should have a different answer. If I'm sitting here in Chennai in the Institute of Mathematical Sciences, this should have a different answer. Okay? So this technically, I don't want to get into too much technical details. These are the things we would like to discuss at length in the future meetings. Technically, this is called the prior. It's my prior probability. It's even before I've seen anything, this is what I assign, okay, this probability. This probability is called the likelihood. This one. It's the likelihood of something happening, okay, given that I already know something else, okay? And finally, this thing is called the evidence. In these kinds of problems, it's not particularly important. It's just a denominator. So if you remember a little bit about probabilities have to be normalized to 1. So that takes care of this for this class of problems, okay? So the general, and this object here is called the posterior. It's the posterior probability, okay? So the general cycle is, I start with some prior probability. I multiply that through the likelihood, which is where all my modeling sits. I get a posterior probability, and then I recycle this over and over again, okay? And that's the learning process. Yeah, so in the next cycle, whatever is my posterior becomes the prior. Again, I use my likelihood, and I get a new posterior, okay? So if the next time around, the participants behave differently, I'm back to square one. So if the next time around, the person who gave me the unfair coin gives me the fair coin, again, I come back, I undo all of the learning that I did, and I should again come to a situation where P is equal to half. But if the next time, the people who gave me the unfair coin the first time also give me the unfair coin the second time, then my probability starts building up, okay? So then I have my biases start building up, and I actually do the learning process in a particular direction.
So mostly it depends on only the previous result. So the learning, the experience is lost here. So you get a new set of things in your previous.
No, it's built up. It's built up. So the thing is that if your data, so this is very nice. So you've heard of data-driven decisions, et cetera, and things like that, data-driven. So the point is that once you started with this is the only place where you're, at the first cycle, where your bias comes in. After that, everything is driven by the data. Once you take this and set it back here at the next cycle, you're not doing anything arbitrary, because this has been arrived at from data, right? So you push it back in here. And if your data is telling you that, you know, the person who gave you the fair coin last time gave you a unfair coin this time, that means, you know, that person can or cannot give you a fair coin. He's not, it's adding up. But in this particular example, it's adding up in a sense which is not leading to certainty, right? But if the same person is giving you the unfair coin over and over again, it's adding up in a sense which is leading to certainty, okay? So that is the very nice part of the algorithm. It does not, so the first time, for instance, if Durai gives me an unfair coin, I think, oh God, this guy is going to out to scam me, okay? But the next time he gives me a fair coin, there is a tendency amongst human beings to have this residual bias that, oh, this person cheated me once, he must be out to cheat me every time, okay? Or something happened once, it must be happening each and every time. What this is saying is that listen to the data more than yourself, more than your biases, Okay? So if this is happening, come back and convolve it with your data. It will undo all your biases. Okay? So that's why this is a very, very powerful way, and sort of, other than putting in your personal biases at this point, it's completely driven by data. So it'll undo all your biases provided sufficient data can be accumulated. Okay? Again, so it comes back to his question that, what is sufficient data? Yeah.
I have one understanding on this.
Yeah.
Please correct me if I'm wrong. So what I understood is, with respect to the probability of P, the basically the upper part is nothing but finding the probability of A with some weightage factor.
Yes.
So what I understood is the probability of A with respect to B is this ratio with the current weightage.
No, so forget about this.
Okay.
This doesn't matter. Forget the denominator.
I'm trying to understand the whole
ratio. The entire ratio. Okay,
yeah.
so the denominator doesn't matter.
Okay.
Because the denominator doesn't matter in this particular problem, because the sum of probabilities must be 1. Okay? So in this particular case, the coin must be either fair or not fair. There are only two possibilities. Yeah. Okay. And the probability that the coin is fair or it's not fair has to be 1, because these are two mutually exclusive alternatives and they exhaust all the possibilities that can happen. Okay? Now, because of that condition, you don't need to figure out what this is, because you can add the probability of A being fair plus A being not fair, and they should add up to 1, and that fixes what this denominator is. Okay? So in this particular case, it doesn't matter. Okay? But I will, so I'm being very quick. So Bayes' theorem is a very deep theorem. It looks very trivial, but it's a very deep theorem. So if you come back later, I will explain this in complete, great and gory detail. Yeah. Yeah. Yeah.
What are the data that you gather themselves are biased? And I think of the example of a recommendation engine.
Yeah.
Instead of coin being fair and who the source is.
Yeah.
How about if you consider the case of I'm Netflix, I'm recommending a movie.
Yeah.
A could be customer likes the movie. B is what the movie is.
Right.
The data here is, does the customer like the movie?
Yeah.
That's biased. That's so subjective. How do you deal with that?
So now you want to ask, what is the probability that the customer likes this movie? So you have to state the propositions clearly. So the data is a certain movie. And the A is, what is the probability that the customer likes it? And what is it that you're saying is biased?
Netflix itself is biased.
So you have multiple biases over here.
Oh, okay, right. So how do you, so that is another very interesting topic. And that, I can tell you about more of these things. So for instance, when you're doing, so this is more like, so I'm giving a very simple and artificial example. When you're actually doing real life problems, you have to involve many more probabilities. Okay. So for instance, the question that you asked is more related to the veracity of opinion polls. I'm going out there in front of my election booth and and I'm polling the people who are coming out. Now, did you vote Congress? They would say yes. Did you vote BJP? Someone would say no. Now, what is the probability they're actually being truthful? Because my final answer is going to depend on the veracity of that. Okay? So then you have to also put in here your bias of what you think is the truthfulness of your source. Okay? So if you think that with probability half, someone in the polling booth is going to lie, they actually voted X party, but they're saying they actually voted Y party. So you have to put in that bias that only a half of my clients are actually, or my respondents are actually truthful respondents. Okay, and that thing, that parameter that you put in, which is your belief for what the bias is, will finally show up in the final result. Okay, and now you have to match your final result. Now this is where in my earlier slide I said of doing the experiment, right? Of doing experimentation. So this is where you have to do the experiment. You have to take a series of polls and hopefully roughly the same kind of sample sets, and then figure out what this parameter is likely to be. How many respondents actually are truthful in their answers during an opinion poll. Okay, so these are all questions of bias of the respondents, not your bias. Okay, so you might be a polling agency which is working for the BJP. It's important that you do not bias your results because you're working for the BJP. Okay? It's those kinds of biases which can be prevented by using Bayes' theorem, not the bias of the respondents. That has to be filtered into the modeling process itself. Okay, so let me just come back to this and quickly tell you about a very simple application of this. Okay, so how am I doing for time? I should wind up in about five minutes. Okay, so very simple application of this is this spam filtering. Okay, so what you do with spam filtering is that what is your, so you again, this is the standard thing about Bayes' theorem. So what is your data? Your data is actually a bunch of words, the bunch of words from the email, right? And given those bunch of words from the email, you want to know whether it's spam or not, okay? And now what you do is you use Bayes' theorem, you turn the thing around, you say what is the probability that I'll get that sequence of words if it's spam, times the probability that I think the email is spam itself, right? Now this is really the key part, and to answer your question, you can see that the denominator doesn't matter, okay? Because I've used precisely that normalization. The email is either spam or not spam. These are the only two alternatives, and therefore the denominator is fixed by this thing, okay? So now this is easy to, this thing is easy to model. What is the probability that it'll get a sequence of words if it's spam? If something is spam, then it'll have, we know the kinds of words it's likely to have. It'll have Nigeria, it'll have $1 million, it'll have various kinds of things like that, right? So this probability I can model easily. If something is spam, what kind of words should it have, right? So, and then, whether the thing is spam or not, I can decide in the first iteration to be half. When an email comes to me, I don't make any prior judgment. I just assume it's spam or not spam with equal probability. But once I do this cycle, this thing keeps developing. Okay, and this is how the spam filters work. They start with the probability of half the mail is spam or not, and it keeps on running this cycle. And sooner, as more and more mail comes in, and each time it makes a successful identification, you tick it and say that yes, this is actually spam. Its confidence builds up on the classifier. And very soon, with sufficient amounts of data, it actually does a very good job of spam filtering. Okay. So I'm going to sort of move on here to something else. Sorry. So I'm going to move on here to weird enough. Something has gone wrong. Okay, that's because I'm at the end of my slides, which I really didn't want to. Okay, so here is basically my very quick 6 steps. Okay, so first of all, you have to identify, going from your data to something which is valuable, you have to identify the problem, you have to identify the relevant data sources, you have to pre-process the data. So if you're just pulling in data from the internet, you have to pre-process it so that it can be fed to your algorithm. And in this case, the algorithm will be some machine learning algorithm. You need to visualize the process. Okay? Whatever your algorithm outputs, you should be able to visualize that process. And finally, Dorai also mentioned this, you should be able to tell a story. Right? Through all of this math, etc., graphics, blah, blah, blah. At the end of it, what is important, what is valuable, is the story that you're actually telling. What is it that you can say which can have an action, an actionable insight? Okay, so this whole cycle you need to do over and over again. So I told you a little bit about the algorithm. I'll tell you very briefly about the algorithm and the kinds of things that can be done. I'll tell you very briefly about the typical ways you can visualize data. So just before I go on to that, again, this is something that Dorai mentioned. This is this very nice machine learning algorithm library called scikit-learn. And this is a whole bunch of building blocks of machine learning algorithms. Okay, and I think because I'm running out of time, I think I should. Yeah, I'll just do the demo. Yeah. So so this is the kind of thing that we want to teach you and tell you about in the subsequent things. But I'll just very briefly look at this nice demonstration. Okay. So what is going on here? Okay. so that takes me out of the screen, which is not so nice. So just give me 1 minute. Okay, so this is an example of data visualization. Now what's going on here is that it's an example of text visualization, where if you look at the names here, which I hope you can see, these are all names from characters in the famous French novel La Miserable, which was written by Victor Hugo in the late 1800s. It's a very, very big novel, very famous novel. These are all the characters in the novel, arranged as a matrix. Okay. What the value of this matrix tells you of this point, so for instance, if you look at Brevet versus Brevet, it tells you how many times does Brevet occur on the same page of the novel. Okay? So for instance, here, there is some character. You go down there, that character. How many times do these characters occur on the same page of the novel? Okay? The darker the color, the higher times this happens. Okay? So if you see 0, it means that those two characters never occur at all in the same page of the novel. Okay? And the idea behind this is to try to find out how two characters might be related. If two characters are occurring on the same page of the novel several times, that means in the story, those two characters are actually related characters. Okay? Now, this is a raw plot of the data, which is organized by name. And you can now organize it by frequency. And something very beautiful happens. This whole matrix elements shift. Okay? All the matrix elements shift. And now instead of an alphabetical listing of names, you have a listing by frequency. So that means this person, Valjean, has the highest frequency. Okay? So this character occurs many, many, many times in the novel. Okay? So just from this pure simple fact, you might be led to recognize that Valjean must probably be the protagonist of the novel. He's probably the main character of the novel. And these characters are in decreasing order, the more and more important characters. Okay? Now, this is one thing that you can do. Now, because you have these co-occurrences, you can build what is called a community network, or you can do what is called clustering, and you can figure out whether these characters who are co-occurring actually co-occur in a further hierarchical structure. Okay? So are there sort of segments of the novel in which a bunch of characters always co-occur? So you have first the co-occurrence of people on the pages, and then at a next level of hierarchy are people organized in a different way. Okay? And that is so there's another algorithm which is being applied, which is called a community detection algorithm. And then you can cluster, and then again something beautiful happens. You see, the data is now clustered into blocks. Okay? So this bunch of characters are one connected part of the story. This bunch of characters are another connected part of the story. This bunch of characters another part of the story, and so on and so forth. Okay? So just by doing pure numerical work, just looking at frequencies and then applying an algorithm, you can already arrive at a gross level understanding of the structure of this novel. Okay? Yeah? For the community detection algorithm? Okay, so it's using what is called this, sorry? No, it's not using k-means. It is using it's using a collocation detection algorithm. Okay, so when you have, okay, so essentially what is a collocation? A collocation is when you have two words occurring together. Okay, so what it does is it calculates the conditional probability of A given B. So character 1 given character 2 given character 3, and it calculates a distance in probability space, something like a Kullback-Leibler divergence between these two probabilities, okay? And then tries to find out, sequences them according to the distance in probability space. Yeah, a symmetric form of that. Yeah. So you symmetrize the Kullback-Leibler divergence. So you have P of car 1 given car 2, and a whole series of these things, and then you sort of calculate a symmetrized divergence in probability space, and then rank according to that. How do you? So this is basically P of A given B. Okay. From here, you calculate the P log P Kullback-Leibler divergence, and then you also say B given A. Okay, it's basically a symmetry. It's so that if you just look at the Kullback-Leibler divergence, it's not a distance in the usual sense, right? It's just some measure. But then you actually to actually make it a distance, you have to symmetrize it. Okay, yeah, something like that. So then it actually becomes a metric in the space of probability. Okay, so you can do something like that. Yeah. So from that, sort of coming back to this thing. So this is an example of the power of pure data mining. Okay, or just pure data analysis and learning. Okay, so from this you've already learned a structure of the novel without even having read it. Okay, and then if you actually, so for those of you who have read this, or you can apply this exercise to any of your own favorite novels. I really want to apply this to the Mahabharata and see how much structure it can induce, because that's a very big novel, lots of characters, and it'll be great fun to apply it to the Mahabharata. And see, so this is the kind of fun things that you can do, and they all rely on, to some extent, probabilities and Bayesian inference and so on and so forth. Okay, so I think that's a good place to stop. I think maybe Doreen, we can come over here and take some questions. Yeah.
You can take, we have a break and then we have.
Oh, okay, right. Okay, fine, yeah,
So we
yeah.
can do
Sure. Okay, great, fine. So yeah.
But you want to show the pandas?
Which one?
Just
Okay, sure. So again, I think there was a question saying that whether R is a useful thing or not. Okay, so I think Dorai has this somewhere that that this year the number of people using R for data analysis has actually just reduced, and the number of people who are using Python for data analysis this year is the tipping point. Okay, sorry, it's always been the same. It's almost the same, yeah, but I think from the slopes you can make out that in another 2-3 years Python will become more important. Okay, so anyway, so this is this really nice data analysis library. It's called Pandas, and this is really what is being used as a replacement to R. And like Dorai mentioned, R is not really a programming language. It's like a little like MATLAB. It's just a language which was kind of cooked up on the fly. It's not a general purpose language, okay? So you're always better off working with a completely general purpose language in which you only need one language to do all the work that you're doing. So all this workflow that I had given of the 6 kinds of things that you need to do, you can do everything in Python. So there is this Python data analysis library. I already talked about scikit-learn. So the idea would be that you import your data into Python through this Pandas library. The Pandas library data structures are understood by scikit-learn. Okay, it actually understands, it's actually very well integrated with Pandas. So then you take all your data, which is in these Pandas data structures, you feed them into your scikit-learn algorithm, and you will get some answer from that algorithm. Then there is this nice Python plotting library called matplotlib, which, let's see if it shows up. Yeah, let's just go straight to the web page. So there's this very nice Python plotting library called matplotlib. So you take your analysis from scikit-learn and plot it and display it in matplotlib. And from a combination of all of these things, you should have a story to tell, which is your actionable insight. Okay. So these are basically the toolkits that we will be using in the subsequent seminars, the lectures, etc. And if you're not familiar with these tools, strongly encourage that you actually see these and try them out for themselves. They're actually very, very nice tools. Just a little bit of history. So this is really, I'm very strongly for open source things. So this library was more or less single-handedly created by this gentleman, John Hunter, who died last year, 2 years back. And it's actually a heroic piece of software development exercise. He more or less single-handedly did it. He was very unhappy with the proprietary nature of MATLAB, which wouldn't let you tweak the plots in the ways that he wanted. He was so unhappy with it that he just actually went and wrote the entire sort of MATLAB visualization engine in open source. Okay, and that is why it's called matplotlib. It's sort of, there's no particular reason for the mat there, but it's because its inheritance is MATLAB. That's why it's called matplotlib. So it's really one example of what. And then his dedication really pulled in a lot of other people. So it's just one example of the kind of things that we're trying to do here. That getting lots of people involved in some effort and building something really nice out of it. Okay, I think I'll stop there. If there are any questions, we can take them now. Or if you want to carry on and have tea, we can do that as well. Yeah. So are there any questions at this level? Or yeah.
Regarding the band theorem,
Yeah.
can we have more than 2 or 3 parameters because we are using?
Absolutely. You can have as many as you want. So the A and B can be many more things. It can be compound propositions. Okay. So I just gave you the simplest thing. So you can have as many parameters as the complexity of your model wants or desires. What I was doing was absolutely naive Bayes. Yeah. So where you actually use the frequencies of things that you've seen before to estimate the probabilities themselves.
Yeah, but there are other competing classifiers like random forest, SVM,
Yeah. So as I said right at the beginning, okay. So all those things are also called machine learning. So random forests, support vector machines, so on and so forth. Those are typically not characterized as probabilistic algorithms. Okay, they are more characterized as different kinds. They're not really characterized as probabilistic algorithms. Okay, my focus here is entirely on those sets of algorithms which will be characterized as probabilistic. I have a very strong reason for that, because if you run a probabilistic algorithm correctly, it has no source of bias. Okay, it just does not introduce any artificial bias. Whatever you put in is exactly what you get out. Okay, and that's guaranteed because. Which is why I mentioned this whole business about reasoning at the beginning, okay? Because it's just operating with Boolean logic, okay? Just like Boolean logic is infallible, if you give the initial propositions, the final answer is completely infallible, okay? Probability theory is essentially operating on Boolean logic, but with variables which are not 0 and 1, but is a continuum between 0 and 1, okay? And now that the rules of manipulating probabilities are essentially Boolean logic rules. Okay, so whatever you put in without any hocus pocus is what you get out. No other algorithm guarantees that. Okay, so support vector machines or random forests or fuzzy logic, all of these things are what I would call leaky algorithms. Okay, you put in something, but there's no guarantee that the answer that you get is absolutely a strictly logical consequence of what you've put in. Okay.
but data shows like most of all kinds of fluid data also, like data is fluid also, random forest also, that's what a lot of data shows.
So to me, so I'm a very sort of rabid Bayesian. Okay, so to me that just basically means that you have not spent enough effort in trying to figure out a good Bayesian algorithm. Okay, so it's very important if you see an algorithm which is outperforming a Bayesian algorithm. I think that's a very good research problem to figure out what is, so essentially that would mean that you have a very good assumption for the likelihood. Mm-hmm. So try and figure out what is the likelihood that is actually going into that model, okay, and recast it as a Bayesian model. That would be my solution. So it is certainly true that things like random forests do certainly better than naive Bayes algorithms. But then if you could actually go to the heart of the algorithm and figure out what is going on and recast it as a Bayesian algorithm, it would probably do better, is what my statement would be at this point in time.
Okay, thank you.
And Bayesian can be used in unsupervised learning also?
Yeah, in fact, it's mostly used in unsupervised learning. Its main utility is in unsupervised learning. Okay, so for instance, in the spam classifier, the initial supervision is only just saying that with probability half, it's either spam or no spam. After that, you just let the classifier run, right? And then it just takes care of itself.
In fact, the mixed ones are supposed to give better results. Partly supervised.
Yes, yeah. So for instance, the spam classifier is actually like that, because every once in a while it'll ask you, right? Did I get it right? It'll ask for confirmation that is something which I thought was spam. Did it actually become, did I actually dump a real useful email into the spam box? Or did I let some useful spam actually get through? So either of these things, it asks you for confirmation, right? So it's a mixture of, a good spam classifier is a mixture of supervised and unsupervised. The supervision is coming when you're telling it whether it got the answer right or wrong. Okay, so looks like there are no further questions. We'll reconvene for, yeah. Oh, there is a question.
Yes. So the sample Bayesian theorem.
Yeah.
First sample we take,
Suppose for a market analysis, so the first sample we take, how do I pick a sample? And if I picked a sample, how do I know that the sample I picked is a correct one? And how big my sample should be? The first one.
Yeah. So you mean, what do you mean by sample here? Is it like so if you just
like I have brought a new product in the market. I want to do the analysis of what people think of it, or how is it doing.
Yeah.
So what should be my first sample, and how big it should be, and how do I know that it's the right sample I've picked?
Yeah, yeah. So unfortunately, none of these questions have very well-defined answers. Okay. So these are not so much problems of learning, but they're problems of sampling theory. Okay, and this is related to the question that I answered a little earlier about election forecasting. Okay, so when you're forecasting an election, how big must your respondent size be? Okay, do I need 100 people to get a good answer? Do I need 1 million people to get a good answer? The ideal situation would be where I ask everybody, but then that defeats the entire purpose of sampling, right? Because I would like to know just by asking a few people what everybody else thinks, right? So, I mean, these questions are very, very domain and situation specific. Okay, so typically when you want to know what is the minimum number of people you want to sort of poll, to get convergent answers, the rule of thumb, at least for these kinds of problems, is that you should take at least 10,000 respondents. Okay, then you get an answer which converges to something. So if you take 100 respondents, you'll get a very large variability. So you want to have a situation where the probability is actually, the probability is kind of sharply defined over some answer space, right? And these are just rules of thumb. Unfortunately, I don't think I can tell you.
Okay, so as we go on with the theorem, maybe the last.
So also the Bayes theorem doesn't tell you about that. So that is something to do with sampling theory. Yeah, so it's more like central limit theorems or laws of large numbers, which tell you when you're adding variables, random variables, how do they converge to the mean. Okay, so Bayes theorem tells you something about the inference process. You have seen some data. What is the likelihood of some statement that you are making based on the data? Okay, but when the data is sufficient, which is a question which has been asked again here, when is the data sufficient to give an answer, is not something that Bayes theorem tells you. Bayes theorem tells you, you give me the data, I'll give you the answer, and my answer will be as good as the data is. Okay, so to answer the question, when is the data sufficient, you have to look at other aspects of this probabilistic process, which are called limit theorems. Okay, so limit theorems. Okay, this tell you when your answer is going to converge to some good value. Okay, so
We'll take a break and we'll come back.
yeah.
We'll have Q&A.
Yeah. So we've organized some very light tea and refreshments just down the corridor. So if you just step outside, and we can reconvene in 15-20 minutes, and then we can talk a little bit more about what we want to do.
So now I have two variables to account for, right? I don't know, is it because it came from a bunch of geeks, or is it because it's something else, and so we need to figure it out. But I think we have some of those problems that you talked about, and we want to take, we'll talk about them. I want to clarify a couple of things. We are focused on doing it on Python and Python tool libraries, for the simple reason that we have to pick one language, right? The possible candidates were R, Python, and we feel that Python is much better because, like Ronoja was saying earlier, you can do everything from one end to another end using Python. So there is no mismatch. But it's not as if that is the only solution available in the world, right? There are people who have been using R. ThoughtWorks uses R a lot. There is one called Julia that has come up, and it says, if you go to their website, they make actually fun of Python, but they compile language, they want performance, all that kind of thing, but it's very, very early stages. Scala is picking up a lot. We see all these things, right? Like ultimately we'll let the data drive us. You see what are the discussions, what are the libraries, and just like we are saying that, hey, we're going to take input data and we're going to, apply the we'll use the Bayesian one to figure out what we want to do too. And that is the proper way to do it. And right now we are using tweets, but we can see other discussions also. So what we would like to do is there anything you want to show before?
So maybe we'll see
Let
any
them-
questions. Yeah.
So why don't we do this? Let's make it just audience driven, right? We'll share one mic. We'll give you this mic and all the questions that you didn't have time to ask for, and however basic, it doesn't really have to be anything like, on this is what I'm trying to do, how do I do it kind of stuff. Like anything at all about this, what we covered, we did it at a very, very high level. Especially my talk was even, like glossing over 50,000 feet. Yes. So feel free, just shoot the question, and can we get them on mic? We should use the column mic.
We'll use the column. I have the column.
You have it? Okay.
Yeah.
So we can
So there's a question.
Yeah, I mean, it will be a repeat of the question in the break, but for the sake of whoever want to ask the same question, first of all, thank you for organizing this, and it's like very wonderful exercise going on. The tough part for a programmer like me, or a domain knowledge person like someone, or I'm also like a telecom domain solution architect. So the problem that we are facing is there are a bunch of algorithms mentioned which can do, this is the way this can be output. And I guess you demonstrated the same thing with Flipcoin example. The point is which algorithm to apply when. This is something which is, little wide question for us. I mean, at least for me, who is like not into statistical background as such. So that is one thing that maybe in future workshop, I want that to be one of the point. And second thing is, that Python particularly, I mean, there are new languages coming up and all those things. And I don't know whether Python can do on Spark and, big data has a background, but R do not have the background of big data. So and eventually, the more the data, the better the answer will be. That's my understanding. So apart from Python, are we going to look for Scala also? That's two questions I asked.
See, if you look at all the big data related technologies, they're all being built with Java for obvious reasons, right? Hadoop came based on MapReduce from Google. Then, Yahoo guys said, hey, we need to have an open source version of it. Then a bunch of people like Cloudera and Hortonworks and all that are working on Hadoop. And then all the technologies being built around Hadoop, Mahout for the machine learning, all these kinds of things, they're all like based on Java. But one thing that they've realized, and the whole world generally is changing in the sense that the services are independent of the clients. That is, almost all of them have Python, JavaScript, because Node.js is becoming very popular as a server-side language, Ruby, C, C++, and of course Java and Scala and Clojure, for example. All these things, there are a lot of efforts. The maturity level of the libraries in the Java world is reasonably good, but it doesn't have the momentum, right? There are two reasons why we decided to go with Python. And I'll answer your question in a minute. I'll come to that. But the two reasons is that initially in machine learning based applications, you're going to experiment a lot. You need to iterate a lot. You need to write a lot of throwaway code. And Python is perfect for that. Ruby is also very good for that, but for some reason Ruby has not picked up. Python is perfect for this iteration. Okay, so a compiled language, strongly typed language, we all know takes a little bit longer to code, but I generally know that having seen examples, you can take anything you can write in Java and you can write it about less than 1/3 of the lines of code or whatever it is in Python. I think the power comes from a couple of very, list iteration and lambdas and those kinds of things, and other languages are catching up for doing this. So in the initial set of seminars we'll teach Python, we'll do this in Python, because we also not only want somebody who already know the language, but if you want to do with Java, you can do. That is not what we will be using it. But the thing is that we have initially, then as I said, that if the demand is more for Scala based, because even Scala is just just being picked up. Twitter uses it. Even its adoption is kind of interesting. We watch languages also to some extent. So, you can look at that. And for all of you, just to see all these languages, there is a site called TIOBE, TIOBE. You can say Programming Language Index. They track the top 100 programming languages, especially the top 20 languages, and every month they update their positions moving up and down kind of stuff, and why. And it's not, the top 5 positions are like solidly taken by C, C++, Python, C#, Objective-C. They keep on rotating themselves. Then Python, Perl, PHP, Ruby, they come to the next slot. And then the other ones, but the interesting ones are the ones that jump into the top 20 from somewhere in 50 kind of thing, and they are the interesting languages to watch for doing that.
So I think, yeah, I'll answer the other part of your question, like, how do you search for algorithms? Okay, so we've taken up the slides, but if we had shown you the front page of Scikits Learn, you'd have seen that they have blocked up their tasks. Can you hear me at the back if I just speak? Yeah, okay, so I'll just get rid of the mic. So they have blocked up their tasks into a bunch of things. So the first is classification, then there's clustering, regression. So these are names. So these are the 3 big building blocks of any sort of data algorithm. Okay, these are telling you what are the top level modules that you might want to use. Okay, so there will be a whole bunch of modules for doing classification, a whole bunch of modules for doing classification, a whole bunch of modules for doing regression. Now these 2 things are sort of self-explanatory. You know what classification means. It means that you have a certain bunch of categories. You want to assign your thing to one of those categories, one or several of those categories. This means that I want to induce categories. I do not know what the categories are. But if there is some measure of similarity, can I sort of bunch these things together by that measure of similarity? So this clustering was the kind of thing that I showed in my talk, where you actually cluster these characters without knowing anything about them. Okay, so there you induce some metric of similarity, and then you sort of use that metric to cluster. What is regression? So regression is one of the classical statistics tasks. It basically says that there is some model which is generating my data. I know what the model is, but I don't know what its parameters are. Okay, and I want to find out what the parameters are of that model. Okay, so a lot of tasks can be just set up as simple regression tasks. Okay, there is some model. I just don't know whether the model has value A or B or C or whatever. I just want to infer what these parameters are. So of these tasks, this is actually the most well developed from a statistics point of view, because this is a very old statistic problem. Okay, so these are the main sort of building blocks of any algorithm, and then there is a sort of side block which is called dimensionality reduction. So this says that I have a huge, like a million variable problem. Can I reduce it to a problem with a smaller number of variables? Okay. So this is particularly important when you have so much of data coming in. Okay. Can I reduce all these informations that I have about the data to a lower dimensional model, which will be easier to compute? Okay, so again, this is very sort of problem and model dependent. But if you really want to ask, starting from the end of a programmer, that where do I start? You should first answer this question. What is the task that you're trying to do? Is it a regression task? Is it a classification task? Is it a clustering task? Or it could also be a combination of all these tasks. And then you accordingly sort of look at the algorithms to start with.
If it's the combination, then I will be applying them independently and getting the results out of them, and then maybe if an example like you can give, or if I can thought of it like, I want, as I told you, we are working on the CDR analysis, call detail records of mobile calls. So we want to do some classifications on that. First of all, regression on that. What if I give a particular timelines? What is the duration of this person is making a call at that particular duration of time, like in the night time, 9 to 3 o'clock. Right. So that is regression. But if I need to identify, okay, what all variable sets which are, that is something the problem statement I'm giving initially. But from the data already having, what all columns are connected to each other, or what all data elements are connected to each other?
Yeah. So problem here is that you have call record data, right? So you have a customer, you know all the calls that he or she is making, and therefore you know typically a lot of information, but let's assume that we are reducing the information only to the duration of the call, right? Okay, so some call has taken place for duration t seconds, let's say, and it has taken place at some time of the day, which let me call that, for some better word. Okay, so I'm going to change my notation. So that's the Greek letter tau, and the time t is when it has taken place. Okay, so this could be, let's say, 130 seconds. This could be 9 p.m. Okay, so your customer made a 2-minute call, a little less, more than 2-minute call at 9 p.m. Okay, and now you have for this particular customer a whole cable of tau 1, t1, tau 2, t2, tau n, tn, right? So you have this, and you have this for every customer. So this is customer number 1, customer number 2, etc. Right? Okay. So now supposing you want to ask, your first question is, what is the bandwidth that my network might need at say 10 p.m. Right? So then you go through this column, look at the time when t is roughly 10 p.m. See what is the duration of all the calls. Okay, for this customer, for that customer, etc., things like that. Now that kind of tells you the amount of congestion that you have in your network at that point in time. So this is a simple regression task. Okay, there's already a model for this, and you just want to know what the parameters of the model are. This is a simple regression task. Supposing now you want to classify your customers into customers who call very frequently versus customers who call very often. Okay, then what you would do is you would probably sum this column. This column sum is the number of minutes the person is calling in a particular day, right? Now, then once you have this column sum, then you want to do a classification task. Is this a frequent caller or a non-frequent caller? Okay, and then you can draw a cutoff. What do you think is a frequent call? That will depend on your business. How many minutes should a person call a day for that to be a sort of a heavy use customer versus a light use customer? So then that's a classification task.
You can also cluster them.
You can also cluster them. So you want to cluster people who are calling each other, right? So, or you can just cluster them according to, without a criterion for who is a heavy user or a low user. You could cluster them into people who call for 5 minutes a day, 10 minutes a day, 100 minutes a day, and that would be a clustering task.
Okay, so classification is like only two...
No, it can be more.
Okay.
You can also do classification directly. But supposing you don't want to do that, you don't want to impute the categories, you want the categories to emerge out of themselves, right? Then you would do a clustering task, and from the clusters you'd be able to tell whether there are 5 categories. There might be, so for instance, you don't know how the behavior of your callers. It might be that there are only 2 kinds of callers: callers who talk for hours, and callers who talk, just pick up the phone, say something ready, and drop the phone, right? That is something which would come out automatically of a clustering algorithm. Once you see the clustering algorithm, then you can say, okay, it looks like there are only 2 kinds of callers, and then you say, okay, fine, I don't need to do clustering anymore. I'll just do classification. So on the new data that is coming in, you directly do classification. But then you've used the clustering part of the algorithm to impute the categories which you would put in classification. Okay?
So since we are talking about this dimensional integration, there are a lot of things we didn't touch upon because we just didn't have time. There's a feature extraction, right? So you need to figure out what are the features that you're going to try. So that is the whole bunch of interesting things, and it's also the iterative model. You start out with, that is the nice thing about this whole thing, is you start with certain assumptions, and you assume that these are the things that are going to make a difference, and then you start observing what comes out of these assumptions, after you process them, and then you go back and change your assumptions. Like the example I was giving is that I capture X amount of information about customer for conversion. Then as I'm doing the analysis, I suddenly find out, hey, it will be very useful if I also knew this other feature, which I don't gather right now. So you start gathering that kind of thing. So it's kind of a discovery process, and it's iterative.
Yeah, and this is where, again, sort of emphasizing what I said. Since this is a process in which you're going to do exploration, it's best you do it in a language which allows for very concise expression, right? And that's where Python comes in. So in that phase where you're sort of playing around with your data, it's a really good idea to use Python.
Yeah, this is Venkat. I'm a data engineer. So when I started to learn data science, I went into Coursera data science series and took 2 courses. Like Dorai said, after looking at all those mathematical notations, I'm taken back. So what is that as a prerequisite that we have to learn before we dive deep into this, in terms of mathematical, in terms of statistics?
Right.
And on the other side, we have various libraries. We have Scikit, we have lots of libraries which says that you don't have to know algorithms. Just pass in the data, get the data prepared and ready. So how much of knowledge would be required, basic level?
Yeah. So I just had this discussion with that's part of the audience. Yeah. I just had this. There you go. I just had this discussion 5 minutes back as to what is the how far do you take a black box algorithm? Okay, so in my pyramid, ideally I had this black box at the top, right? That you send in data and out comes your inference, right? Now that is the thing that so various people will have to use various things. Like if you're a developer, that is clearly not the level of competence that will suffice for you. If you're somewhere at the managerial level where you are taking the decisions based on that actionable thing, then that is the thing that is sufficient for you. But if you actually really want to start taking these black boxes apart, understanding what is inside them and maybe try to even improve them, then you have to understand what the black boxes are doing. And for that level, the amount of mathematics that you need typically would be what is taught in a good undergraduate physics or maths course. Okay? It really does not need anything much more than that level of mathematics. So what you really need is basic calculus, basic probability theory, basic linear algebra. Okay? You really do not need much more than that. So if you just have these 3 tools under your belt, it should be sufficient to understand most of the families of the algorithms. Okay, but probability is very important. Probability is a sort of central part of all of these algorithms. Okay? So, and the other 2 are just used as tools to manipulate probabilities, the linear algebra part and the calculus part.
The other thing is, as typical programmers, what we do, we'll do what is called the on-demand learning, right? Yes. So best thing is to take a problem, write your own spam filter, right? And you have anyway you can test it with Gmail kind of stuff, dump all your Gmail, don't delete your spam, do your spam filter, try to write one, okay? Figure out what are the things that you need, right? Pick any problem. I'm just using spam because we use that as an example. You could do, we tried a variety of things. Sometimes you don't get the answers, and for mining topics, we tried some 5-6 different techniques, and not all of them had to do with machine learning either. So one thing is that you will start hitting, and for example, for a long time, I couldn't figure out this entire word vectors business, right? I said, oh, I get a document and I vectorize it. I mean, it turned everything. I said, what cosine distance? I said, what is this? I said, why should it be 1? Then I went back to basic trigonometry. A lot of things, what you can just go back and say why, and you will either hit a Stack Overflow answer to it, or actually Reddit has a really good discussion on machine learning, and you can follow the thread. So there are phenomenal resources. That's one of the things we'll do, and I'll just say it now instead of taking up time later. So on the website, we have, if you go to our contact us page, I think we put in a Facebook group, a LinkedIn group, and we'll also start a GitHub, where we'll share every piece of information that we come across. And then what we'll also try to do is, what we'll also try to do is try to provide some guided paths through these kinds of things. If you want to do this, maybe you can do that slightly. I think that will be helpful, because it would have been very helpful for me to start, and it's still helpful, because I have the luxury of coming and bugging him when I have a question about why does it work this way kind of stuff. So that is one thing, we'll try to do that. And we'll have a frequently asked questions. And so if you leave a question, if we can't answer it during this session, you'll certainly find that as an answer in our website over the next week or 2. We'll update that and do that kind of thing. Yeah, go for it. Okay.
So, with respect to this big data, right? We understand, we can build products, and we see products that can kind of support us in the big data analytics, right? Now, is there any products that are available supporting the algorithms? For example, let me take an example where I have an use case identified, okay, and I have different parameters for evaluation, and finally I identify, okay, I'm best to use these kind of algorithms. So I understand there are technologies product in the big data space, but are there products really which build these algorithms? So I can give these parameters, but then the results are got.
So that field is not as developed as we'd like, but I'll give you a couple of examples. I'll point out to a few companies. One example is Google. So they have a prediction API, which is a black box approach. So when I first heard Google introduce prediction API, probably in 2011 or something like that, they would say that you can send an email and it will tell you what language it is. Is it Spanish? And then you can route your thing based on that kind of stuff to different people. So there are some services, not as much as we would like, that are available to make these as blogs in the cloud, actually. So, for example, the Elastic Cloud, but Amazon itself has started building. I think Azure has one. Microsoft has a Azure ML, which is I've not really looked into it, but I just read about it a little bit. Google has this API, but I heard that it's kind of restricted. But I know that one guy built a business just based on Google Prediction API. And then he provided a very easy user interface where people can navigate and then upload their data and then start getting results based on that kind of thing, if it fits that problem. The problem with black box kind of approaches, well, they are good starting points. You cannot iterate and improve them over a period of time, but they're a good one to get started. If you want to like a what if analysis, will this work, and let me throw it, and and they handle huge amounts of data, and they're available as a cloud service. So there is a site, it'll come to me, which lists all the APIs available to you. So I'll do that. I'll put the link to that site. You can just go and type in, let's say speech API, it'll give you a list of speech APIs. Machine learning libraries are coming. I've seen at least 5 or 6 of them, but nothing that is available to you as these things are. But some of these libraries are also moving towards scaling, a web scale computing kind of thing. Some of them are, like they start putting on top of Hadoop, for example. How to take, now I think it's more Storm and other kinds of things also. So they started building this on top of existing libraries that provide distributed computing kind of stuff. And I've seen a few, but I'll locate them. The best way to do it is, there are 2 ways to do it. There is this thing that I mentioned called KD Nuggets. Letter K, letter D, Nuggets is Nuggets. It's one of the best sources of data science tweets, and they point to a lot of things like challenges. And the second one is there's a company called Kaggle, Kaggle. They run machine learning competitions for companies. So I said I'll mention Netflix earlier, and I forgot to mention it, is that they ran a competition and awarded $1 million or some multi-million dollars to somebody who improved their algorithm by 2%. Recommendation algorithm. Okay, because they get more, if you do the right recommendation. So if I see a recommender, and we talked about it earlier in the earlier session, right, and it gives me the wrong recommendations, I'm never going to believe it. So especially in the case of movies, if it can recommend, it's a they can definitely make more money. So the Netflix competition, how it was run, what was the algorithms, what were all the submissions, everything is public, open, available. So you could look at that. Going back to your original question, I think it is happening, but it's not happening in the kind of level that we want. But that's because it's a very nascent stage.
Okay. One more question.
Yeah.
Now, since we see different products, right, for each of these layers, then obviously the natural question that would come is in the integration, right? So is there any standards that are evolving or any forums that are coming up with standards way of integration? Because every vendor will come up with this own way of doing things, right? So do you see any
no,
standards?
I think I'll just like make a very broad answer is that REST APIs are the way you're going to do, right? Almost all these guys don't touch the vendors if they don't provide REST APIs, or you can go build a layer of REST API on top of it if you want.
Data model. Is there any?
I don't know the answer. I don't think I know the answer to that question, but let me think about it a little bit, because there is no one particular data.
Is your interface, how you communicate.
Correct.
How to communicate is your model, right? Basically. So is that?
Well, no, what you communicate is a service. For example, think about clustering as a service. So I may say my interface is I'm sending a bunch of documents. Okay, I want to get back, a bunch of clusters they belong to, for example. That could be a very high-level service, right? If it's more numerical data, then you have a slightly, I send you a data frame which is in our pandas kind of thing, like a matrix or something like that, and then I'm going to get back this information. So I can be at that level, but I don't know whether any deeper levels. We can look at those APIs and come back with some. You had a question?
Yeah. See, normally when an IT industry, initially it started with ETL, okay, and moved to business intelligence, and then it slowly moved to analytics platform, okay. Now it's slowly getting into big data, things like that, where we do a little bit of analysis like classification, clustering, not in machine learning, okay, a normal way of doing it, using algorithms. The next generation, what we see is machine learning, okay. So do you think the IT industry is much matured to adopt the machine learning kind of things, and is it created that much awareness, or is there industry demand in the market?
So, a couple of things. This morning, I tweeted one about BI becoming a roadkill, right? In fact, they're joking even about Hadoop becoming a roadkill kind of thing. So this was a little extreme, and it was like a very provocative title kind of stuff. I think what will happen is that IT industry moves based on the demand, right? We announced C# courses here even before the first version of C# was introduced by Microsoft, right? Which is typically what happens. You can see a huge demand for data science, and so it will start happening. Second thing that will happen is the really good programmers, above average, who are always hungry for doing something different, they're going to look at bigger challenges than creating a web page or doing all this. So I think some part of the IT industry will definitely start moving towards solving more complex problems, because that's how they can get more value out of this kind of stuff. I don't think it is too matured, because every BI group that I have seen is now suddenly become aware that they may just disappear, right? And because if they don't pay attention to this kind of thing. But as having said that, there are still COBOL programmers around. They're still making money because there is this huge, inertia in the industry to move forward kind of stuff. So I won't predict anything, but I think the awareness is increasing. So there are a lot more. Somebody saying that data science is the sexiest job, for example, is one such. If you look at the trends, 2015, it's among the top 10 jobs that comes in. And once that happens, and then I had one slide, I took it out, is the salary of data science professionals. Right? People say, hey, why are these guys getting paid so much? You know why? You need to have all those skills, and you need to be damn good at it. And you need to be a self-learner, because none of the universities teach these courses. In fact, there are a bunch of universities teaching these courses. The fact that you mentioned Coursera, all of us took that Andrew's course, right? And then it goes like this, SVM stuff. So there are all these MOOCs and other kinds of things that are happening. That's one of the reasons why we also thought we should start doing something in this space. But actually, by building things, you'll build the skills. And nobody is going to just take a certification for it. Yeah.
There was Azure cloud service with ML services, as well as I think 1 week back Amazon AWS ML has released.
Correct.
And then you could, for each of the predictions, they charge few cents for predicting. So you upload your CSV files and then what you want to predict you can train. But the problem is you don't know what regression models they are using. So it's just a black box and you can't tweak them.
Yeah, you can Google for machine learning as a service, and you'll find a bunch of things in there.
No, but I think the point that he's raising is
you won't.
that, they are just complete black box algorithms.
Yeah. So.
And I mean, if you don't have an
and you pay some few cents for prediction, and you don't know whether that is correct or not. So instead of that, better to build models based on data what you see.
No, they'll actually, I think they'll publish, but the thing is, for them to be successful, they have to also evolve, right? So, any other questions? Yeah.
Thanks for the good session. I have got two questions. One is on typically, slightly moving away from the technical side of it. When it comes to implementation, typically, how long does it take based on the organization? And the other problem that we see is merging the business and technicality, right? You know that the tool can do this and all those stuff, but on the application, probably the person could be very good at programming and analytical skills, but what is the business demand has to be interpreted. Is there any role in between as, knowledge worker who will be working on it, or it is a responsibility of the data scientist or whomever to identify this, and how long does it take typically?
So there are, I think it's a good question, and I think it is the key to a lot of adoption. So the way you would go about something like this is that you see in your industry, somebody uses machine learning. So the credit cards and the actuaries and the financial services did this first, right? You start looking at these industries, what they are doing with machine learning, so that you know it is mature or not kind of stuff, and see how you can apply. So let me tell you, as simple as a startup. So I was looking at some of the problems of the startups because we help some incubators, and they said the biggest problem startups have is that now especially they have a lot of freemium, what is called first free, then premium products coming out, and they get suddenly 100,000 people coming to their website and trying out trials. They spend a lot of time on servers and all that sort of stuff, but they want to have a marketing sales team to follow up, and they can't follow up 100,000 people, no matter what. So they have to pick and choose. They have no method of picking and choosing. So if they have some, initially let us say we start with a thing that I have to follow everyone, I'll randomly sample about 10% or 5% depending on my capacity. Then what you start is you start seeing conversions. Then you start seeing why are these people converting. So to take any problem and find a programming solution, you have to first see a manual solution of how it will work. That's how business analysis is done, right? You need to go and find out, hey, this works. Can I find out this information? What is the trend? For example, adoption of social media for marketing and sales. How have small companies done it, medium companies done it, big companies done it? You start getting some ideas based on that kind of stuff. So,
when is the next planned session, and will be getting any invite or?
Okay, good. So this is my chance to ask you a question. So originally we thought we'll do a 3-day workshop, and this was supposed to be an introduction section in 3-day workshop. Then we said, okay, let us do one free introductory session, just see what people need, so that we can at least, we don't put in a syllabus that is out of touch with what people need kind of thing. Then we thought, maybe we should do a series, once every 2 weeks or whatever period of time, of one session each, and take each one of these things, like maybe one on classification, one on clustering, and that kind of stuff. Okay, you, the audience, tell us, would you like a 2 to 3 day intensive workshop and go through everything and we put it in your head, or do you want like phased out one by one hands-on workshop where initially, of course, we'll teach you Python, but just enough Python. I can tell you that in what the Python you need to know, it can be taught in half a day's time, right? So do you want what are the, so let us see show of hands. How many people want a series of seminars, once in every 2 weeks or whatever period?
More than the entire audience.
Data doesn't lie, right? So, exactly. That was our thought too.
Yeah, so hypothetically, supposing we had sessions where we would sort of run through each one of these things. So one session entirely on classification.
What do you plan to do in these sessions? Whether they are together or spaced out? What is the agenda?
Yeah, so the agenda would be basically to take a task which ideally one of you would propose, for instance, the call data record task, okay? And just illustrate what are the typical things that a business wants to ask from that. And then as maybe they're asked, how do you translate that business question and the data that you have into a well-defined mathematical operation on the data, right? Typically that would be the first key step of the thing. And then once you've translated it into a mathematical question, what are the algorithms available for you to answer that mathematical question? And if there are no available algorithms, how do you actually construct an algorithm which will do it? That's typically roughly what we are.
I don't know if it's feasible, but if you could define a problem for which we could get the data from the web.
Yeah.
Sure, absolutely.
Yeah, there's a lot of data available. Yeah. So there are two ways again. So I was telling someone else, now ideally, and we will find out whether we can do it or not. We'll do some generic things like classification. We'll take some data that's available on the web and do it. Then if you are interested in doing it with your own problem, you bring your problem, small team, group of people, you can work on yours, for example, in the afternoon. That kind of stuff. Then you also take something back to your stuff, but we can do both of these things. Correct. No, it will not be a single problem. It will be a series of, obviously, correct. So.
Like I was just talking to Ronajay regarding forming teams to attack Kaggle problems maybe. So we have a lot of classification problems, regression problems grouped, and then we get data, and then if you submit we get what is the accuracy of the model, what we did. So that I was just sharing with him if we could.
Yeah, it's a great idea.
So
yeah, but we are kind of a long way away from it, to be very frank. Have you taken a look at the Kaggle problems? The last 10 of them, for example?
There is a Microsoft malware challenge going on right now. So
correct. So I look at it. In fact, I even recall sending him some email saying, "Hey, we should go after this problem," or something like that. But I think we will get there. But we need to, because that is the only way people will notice you. Like Google Summer of Code is for students to get into the live, radar of big companies to hire them. Kaggle is a way for data scientists to be recognized in the world. It's a badge of honor, if you participate and get into the top 10, 20 kind of thing. So, for all of you who didn't understand what that conversation is about, there is this company called Kaggle that runs data science competitions for companies. They, Intel, I think a whole bunch of them. So they, like top coder competition for coders, Kaggle does it for data science. So you just go to kaggle.com and you can take a look at it. GSOC, Google Summer of Code. That's for students. And we have one student sitting here who participated in it. So twice? Once. Yeah.
Thanks everyone for organizing this session. I think it was very helpful for me to know.
Okay. Any other questions?
How is the job salary
in India? So you go to indeed.in, okay, INDED.in. Okay, you type, you pick your favorite city. No, don't worry about it. You asked me a question, I'm giving you an answer. So you pick your favorite city and type data centers. First of all, whether any jobs appear, you see first. Okay. The next one is we can look at. I think what is happening is that Bangalore. Have you heard about Mu Sigma? $1 billion valuation. Okay, they take a lot of students from PSG College. Because I think their HR guy was graduated from that's what somebody was telling me that other day. But they take a lot of students, and now people have come out of Mu Sigma and they started going for higher studies and doing other kinds of things and all that. So just follow a few companies like Mu Sigma and follow a few conferences that are happening. We saw a couple of them in Chennai, but we're not that impressed by what is being covered and all that. So there are a whole bunch of companies. Go Google for companies with the analytics in their name. It'll be a kind of long search for you, but these are all the things you need to do to find out kind of things. The salary mismatch will not this thing unless if you have a PhD in math, maybe it's a slightly, or a bunch of PhDs in math or physics or whatever, it is slightly different. But I think initially you can take contracts or you can bid for these things. So the step would be go to a Kaggle competition, just get listed at least among the top 100 or 50 or 20 or whatever. You'll get noticed. These are not the kind of jobs you'll find on Odesk and freelance and all those kinds of things. So it's a much tougher sell because people themselves are not convinced that machine learning is the way to go in certain. So you need to find a good problem to solve. The other approach, and an approach that we're going to take in Future Focus and stuff like that, is we're going to create a bunch of well-known problem solutions and open source the solutions and explain about how they come about. And that's a way to attract, that's a magnet, right? So I'll just give you one slight example. There's a company called HubSpot. They're a leader in social media marketing. They IPO'd recently with some huge valuation. What they did was they just created a small tool called Website Grader. They gave it away free. You can go there and type, they don't call it Website Grader anymore, but you go and type it and then it'll say your website has a rank 86 or 54 or 23. You type in your competitor, it'll give a rank, and then they'll give you 10 things you can fix with your website so that you can go up to that grade. You know how many uses of that product was done? 5 million users. And HubSpot doesn't sell this product and it's free. So what happens is that's an entirely different discussion. How to create these little teaser products that put it out to gauge interest in people. So for example, in another customer's case, we're saying cleandata.com. You give us any data, we'll clean it up and give it back to you. And clean up means IBM, maybe International Business Machines, I.B.M, IBM, normalize all those kinds of things into map into one canonical form kind of thing. A service. You put it up and say, we'll do it free for 1 megabyte of data. They're not your customers. The 1 gigabyte guys are your customers. So there are all these techniques for doing this kind of thing. So you have to be internationally visible for getting higher salaries at this point in time. That is the conclusion. So.
Maybe elementary for some people here. So in your experience in problem statements you have seen, right? What fraction of the problems need machine learning? Is it most of them or small fraction of them?
The frank answer is I haven't seen many problem statements. What I've been trying to research to find out. So I've been coming up with a bunch of problem statements that will be helpful for 2-3 industries. One thing we are trying to do is jobs, right? The customers send us job requests. Can we cluster them and find out where the clusters are, for example? Can we take the skills and group the skills together to find out what skills go together based on the job descriptions of this? And then similarly we get a stream of resumes, do similar skill clusters from there and see whether you can map them, right? These are all things which is completely somewhat, well, it can be partly supervised learning also. So we are starting with some of those, and then Twitter streams and watch what are the kind of demands that are there in for skills and jobs and that kind of stuff. So that's all jobs related. The other set of things are startup related, which are mostly marketing related, not startup. How do customers churn you? How do you prevent it? It's a common problem a lot of people are trying to answer. There is no single solution. So if you say customer churn predictor and give a simple model, like this is what SAP, Pentaho and others did, right? So they'll give you some solution that is not enough. So you need to buy consulting to take that and adopt it for yours. So that could be the one. So going back to this problem, I've been looking at problems more than getting problems. at this point in time. We were hoping that you'll all bring one problem each, but
Some of the concepts itself, a lot of problems are coming in my mind.
Good.
So we will do it. One thing, please correct me if I'm wrong. What I believe is we can apply the machine learning to almost any systems. If I'm not wrong. Learn over the time
I would use one word that I think Ronuja used profusely in this thing. If there is uncertainty, yes. If there is certainty, for example, the earlier problem that was being the call records problem, I was thinking, wow, it looks like a database problem to me. Yeah. Like I can think about a SQL table, I can put these things, I can sort it, I can get the mean, So there are, I wouldn't say every problem is a machine learning problem, but it has a lot of potential. I think discovery of the problems itself is one of the opportunities. So.
Absolutely. Apparently, they use machine learning algorithms.
Yeah, they do.
Wow. That means we need to do better. There's a business opportunity here.
Do they have a feedback mechanism?
Which one?
Do they have a feedback mechanism?
That's the iteration.
Yeah.
No regression model will work.
Yeah. Okay, so the couple of things to mention. So we're going to we just put up one website just for this event, right? We're going to continue to improve it, but there is a Facebook page. It's called, I don't know how many of you are on Facebook. Some people don't like it. So we created a Facebook page. We created a Facebook group. We also created a LinkedIn group. Depending on which one you like, we're going to put all the links in these places. It's called value from data. That is, if you go search value from data, that you'll find that. You just request, they're all moderated groups. So one thing we can do, if you're okay with it, Rajesh is here, we can shoot you an email with all these links. We don't want to spam you just because you came to this event, but if you think it's okay, we can shoot you a link with all these group names and all, but we are also putting it on the web page and contact us page. So you can go there and send in questions. We'll set in some way, but right now send us an email and we'll get the value from data working, but whatever email is there, you send us a question and we'll try our best to answer it or at least cover it in some future seminar, suggestions and stuff like that. Okay? All right, with that, is there anything else? Yeah,
value from data is working.
The email? No, not the Focusite one. Focusite has been working. So where is Faisal? Ask at value from data is working? Okay, so if you just say ask at value from data.net, not .com, it'll go to somebody else. If they don't answer, don't blame us. .net, value from data, that is the one. Without any word, .net. Ask at. There is also info at, sales at. Yeah. So you can just send a. We don't have a tell yet right now, but you can ask questions. What we'll do is, if there are common questions, we'll put them in the frequently asked questions section of our website. So, okay. All right. Thank you for coming and thank you for staying for such a long time.